Assalamu alaikum, ladies and gentlemen, welcome back to another live stream. Right, long time since I've streamed. Let's copy the video URL, let's share it. Please join my Discord server. Here you go. Alrighty, let's go, man. Alright, let's grab the chat, pop out the chat. If you guys have any questions, please let me know. I'm gonna try to not explain everything to save up time. But if you guys have any questions whatsoever, please let me know. So we're gonna call this, I don't know, let's call it codoxal. Of course we're gonna go with C23. And let's create this. Creating a new project. So we're gonna be using no libraries whatsoever. We're only gonna be using Win32 and Vulkan. That's pretty much it. Not even the standard library, at least for now. So let's go. Well, first of all, let me make sure everything is fine. By the way, is the stream fine? Everything seems good to me for, yeah. Is the stream fine? Seems good to me. Okay, anyways, so let's see what we got here in the settings. Let's go with build execution deployment. You don't have to use C-Line Nova, that's what I'm using. You can use whichever IDE you want. I'm going to be using CMake. So CMake, and I'm going to be using MinGUI, MinGW compiler, because I hate Visual Studio compiler like MSVC for C development. It's just super bad. MSVC, I love it for C++, but for C, no way. So use default Ninja and Ninja generator. Okay, and yeah, that's pretty much it for that, I think. Did I miss anything? Yeah, pretty good. Alright, so let's get into it. Alright, so we have our CMake. First of all, I don't need this guy. And we're gonna call this project name. Of course, I'm using modern CMake. And so we add an executable that is gonna be a Win32 executable. And also, you know, set the properties, I believe. So target properties. I'm using Git pilot, by the way, and hello Arab, or yeah, welcome to the live stream. How is it going, bro? C standard 99. Well, for this I'm gonna be using C standard required, I think equal to on. Oscar Smith Jones, welcome to the live stream. I'm glad YouTube recommended your stream. Thinking about learning Vulkan. Welcome to the live stream. Welcome. So I'm still a noob in Vulkan, although it's been around maybe 1 year that I started learning Vulkan, but I'm still pretty much a noob. But I have recreated I'm trying to create a game engine or a UI system or whatever using Vulkan for a long time now, and I keep on recreating it from scratch because I always keep on going that rabbit hole of abstraction and that rabbit hole of making the projects more complex and craziness like that. So this time I'm gonna try to make sure to make as simple as possible and to narrow the scope as much as possible so I don't get distracted, you know. Hopefully I'm gonna try. We'll see how it goes. Why Vulkan? I just pretty much love Vulkan API. That's first thing. Second thing, speed. It's very fast, like the best performance you can get. A third thing, like you don't really have an option, honestly. You have the other options are DirectX, you have OpenGL, and you have Metal AP, and they also have WebGPU. Actually, you have an option, but I'm coming to that. So you have Metal. Well, that's only for Apple products. You're locked into that. You have DirectX. You're only locked to Windows products. While indeed, I'm gonna try to narrow my scope to only Windows platform, because cross-platform is just like, bruh, too hard to. You just go insane when it comes to cross-platform stuff. So I'm just gonna stay with Windows. Anyways, you have WebGPU. I recommend WebGPU over Vulkan, honestly, but I think I'm a freak, so I'm going with Vulkan anyways. But I'd recommend WGPU but I don't recommend, for example, OpenGL. Though, I mean, you could go with the learning experience. Anyways, let's not waste too much time. Let's just get into it, and hopefully I could. You can see what's going on with the projects. Anyways, so property C standard required on. Okay, and let's set the target. Target compile options, features. Yeah, project name private CSTD23. I'm gonna be using the latest standard of C, and we're gonna link. Yeah, we're gonna need the Vulkan headers, and we also gonna need to pass in some compile options. So the project name, yeah, I'm a very pedantic person. I love the quality of my code, so I always go with the WAL. Not all that crap. Let's remove that stuff. Only up until here, yeah. So -WAL to basically enable all warnings, -W extra to enable more warnings, and -W pedantic even more warnings, and -W error to treat warnings as errors. And of course this is not needed, this is just me being pedantic. Anyways, so target compile definitions. Well, right now what we're gonna need, we're gonna need some more options. We're gonna need -W, I believe M Windows, was it? Because we're gonna be making, instead of using int main, we're not gonna be using that. We're gonna be using the main, because the main is the entry point for the C runtime, like the libc, the standard library. But no, we're just going to be using Win32. So we're going to go with -M Windows. For if you're working with MSVC, you got to actually do something different, which is /subsystem, I believe, Windows or something like that. Or maybe you have to do WinMain CRT setup or some crazy thing like that. I don't remember, honestly. But either way, -M Windows and also -M Unicode. We're going to be using Win32 Unicode. Okay. We could actually support both Unicode and non-Unicode, but I'm not gonna go that way because it just make a soup of macros. I don't care. Like if you're making modern products, like who cares about ASCII anymore? Just go with Unicode only. I'm not gonna be using macros, honestly. So anyways, so target compile options. Let's just reload this and see if we missed anything. Great. Okay, so let's start with the include windows.h. Okay, and I'm gonna define some couple of macros for Windows. Win32 lean and mean. There you go. This is just to make windows.h header include less stuff that you usually don't need. And also we're gonna define define Unicode. Well, actually there's no need for it because it's actually good, since it would error when I don't use the specific function. Anyways, whatever. So now let's just make the WinMain. well, not the normal WinMain. Okay, there you go. Notice that I'm using GitHub Copilot to do the stupid, you know, stuff that you have to memorize. So instead of basically search, like basically what AI does is just like a glorified, you know, search engine that can actually read your whole code. That's basically what AI is. So anyways, into Win API, this is basically a CD call. This is the calling convention of Windows. WinMain, notice the W prefix because this is the Unicode version of WinMain. And since I'm passing -m Unicode, I need to pass this so it would hook into WinMain to the Unicode version. But anyways, H instance, I need that. hprev instance, don't use this. It's just some deprecated cruft of the Win API. PWSTRs, command line. This is the command line that is passed by. If you want the arguments, you have to parse it yourself, but we're not going to use command line for now. Command show, let me show you what is this actually. Hold on a second. So, I don't have an application here. Interesting. Let's say, can I grab Godot or something? Or let's say Steam. Okay, let's say Steam. Can I make a pin? How do you freaking make a, hold on. This Windows 11 just sucks. Anyways, so let's go show more option properties. Okay, so when you are in this place, I believe if you, yeah, there you go, run. So you can change this to either start the application as normal window or as minimized or as maximized. This thing right here is basically this thing. So yeah, let's try this out. This is just a message box, and notice that instead of using message box only, I'm going to be using message box W. I'm always going to be suffixing W for Unicode version. If you just use this is actually a macro, which sucks, and it would basically, depending if Unicode is defined, it would actually map to either message box A or message box B. So W, right? So this is the ASCII version and this is the Unicode version. But in my code, I'm just going to be using the Unicode version exclusively. I don't care. Okay, so instead of null though, we're just going to be using null PTR because in C23, you don't have to use that null constant macro anymore. There's actually a keyword called null PTR, just like C++. Great. Here, L prefix for the Unicode text, because we're using the Unicode version, and let's go. Okay, cool. So let's try this out. We should get something up. In use parameter, yeah. We're currently not using that. Void and CMD show. Okay. Let's see if this works by any chance. And define reference to WinMain. Did I miss something here? Dash. Oh yeah, my bad. This should go to the link arguments or the link flags. So target link options, right? And there you go. -m Windows and -m Unicode. Of course, if you're using MinGW. All right. And let's go. We got hello Windows. Great. Now let's open up a window real quick. First of all, we got to register a window class. So how are we going to do that? Well, let's create a window class. WND class. Actually, let's just say register class XW. And let's say yeah, like this. WND class XW, right? And let's actually do this. What's up right now? Does not name a value. What? Did I miss something? WND class X W. What's up? Yeah, it is correct. So what the heck? I'm not sure what it's talking about, honestly. Well. Nope. Register class W. Let's go with that. WND class W. Let's try that. Okay, that seems to work, I guess. What about XW now? So X basically, the X suffix is for extended. So there is register class, the normal one, the simple version, and the extended version. So let's go. So the CB size is like the size of the struct, size of WND class XW, style CS each redraw and CSV redraw, div window proc, H instance, Lloyd cursor W. Is implicitly, could just use the ASCII version here, H brush, L window class. This is the window class name. Anyways, let's see. Let's create now a window. Yeah. Create window XW. Let me enable auto formatting actually. Auto format. Actions on save. I like the idea of making game engines to learn more, and the idea that I'm controlling every bit in my game with this method, but I'm now too far from this. Yeah, it's pretty amazing. You learn a lot of stuff, but it's too much work, especially with Vulkan. Crazy, man. Too much work. Optimize imports, rearrange code, run code cleanup. Let's go. If you guys have any questions, I'm gonna try to not explain too much so you can do it really quickly, hopefully. Otherwise, just ask me questions and I could hopefully answer them. Instead of null, can we use null PTR now? Null PTR. The AI is not trained on the newer C. WS overlapped window. So this is the title, right? The window title. And in fact, yeah, let's go with that. Auto const window title. Let's go, man. Let's do. Can we actually do that? I think we need WCHART here. Okay, the window title, we pass it here. Actually, we're gonna have, so to keep the narrow scope, we're gonna use one window. We're not gonna do a rendering like for multiple windows and all those abstractions, because that just makes everything much more complicated. So one window, and also we're gonna have, so minimal error handling to keep the code readable and to keep the complexity down. I'm gonna show you how you could, sorry, not minimal error handling, because I didn't learn any low-level language. I'd recommend starting with C if you're gonna go with a low-level language, then learn Rust, hopefully. Minimal error handling, and we're gonna go, though I'm gonna show you how to do proper, like not proper, but like do error handling in Vulkan without doing error handling in your code. Like in debug mode, you could just go into Vulkan configurator, which I'm gonna show you in a second. But anyways, minimal error handling, and we're gonna use, by the way, designated initializers. right? Designated initializers is like this. So instead of like doing this, so this is your window class, autoconst window class. By the way, there's also auto in the newer C version. So that's great. So instead of doing something like this, where you create the window class first, then you pass the reference to it, using designated initializers, you don't really have to do this. Like, instead of doing this, you could just put it directly here, which makes the code much more concise, pretty much, in one statement, except the basic C class 18 in university. Yeah, C is pretty much the best thing you can start with when it comes to low-level programming languages. All right. So let's go. We got the window title, create window XW. There's the X style, which we don't care about right now. LP class name, which we have set. So you can set it to whatever, doesn't matter, as long as I believe it should be at least one character, I think. It doesn't work if it's an empty name. But yeah, X, Y in width, in height, parent, the menu in the instance, and L param. We're gonna use the L param for something in a second. But yeah, show window, and this actually gives us the window, right? And let's just show window and give it the NCMD show. Let's see if this works by any chance, unless if I missed something. Okay, we got a window, but of course it closes directly because we haven't got a main loop yet. So let's create a main loop. While get message W. Okay, great. Message, null PTR, 00, translate message, dispatch message. This is kind of like the pull events, basically. But anyways, let's try this out now. Also, this gotta be, I'm gonna call this message. Message. And here I'm gonna return message.w param, which is gonna be the return code. Let's actually try to debug this and see if it works. And there you go. We got a window without using any libraries, only Win32. And in Unicode even. What I mean by Unicode is that right now you can actually take an Arabic name like this, take it here, hopefully, if everything works well. Hold on, what the heck I done? Okay, there you go. Let's try this out. And there you go, Unicode works. So you can use Chinese, Arabic, whatever, doesn't matter. Anyways, that's what you get for using Unicode. All right, let's go back. Now let's actually put this into, so we're gonna have one struct and one file to keep things very simple. Because like as a beginner, I always got in the rabbit hole of like abstracting things and making multiple files and all that crazy stuff and making crazy error handling schemes, and which always end up overcomplicating the project. I'm not gonna do that. I'm gonna do the absolute minimal to get the project going, to get something working. So okay, so we're gonna go with struct app, only one struct, which is gonna contain all our stuff, at least for now. Maybe later on we could possibly, but yeah, I'm gonna try to avoid that as much as possible. Anyways, so we got struct app. So now we're gonna store here the H instance, which we get. So this is like a handle to our application basically. And I'm just gonna call this H instance like that. And HWND is the actual window handle. All right, great. So now WinMain, I don't need these anymore. And now here's what I'm gonna do. Yeah, implement then refactor, exactly. So let's see what we gotta do now. So let's make this into one function. Void create window, right? And we're gonna put this stuff right here. Gonna put it here. Let's go. And each instance. Also, we're gonna have the application name here. This should be fine, I guess. Window title, each instance, and the window. Now here we're gonna pass, here we're gonna pass in a pointer to the app, just to keep things a bit organized. App. What's happening? Cannot resolve symbol. Oh yeah, my bad. I thought I was going with C++. Alright, so type dev struct app, or struct. Oopsies. So in like C++, if you want to declare an app struct, you could do it like this. Otherwise, you could leave it like it was before, but you have to say struct app like this, which kind of suck. So let's just go back and do it that way. Well, I lost it. Anyways, so let's say type def struct app. Okay, there you go. Okay, great. So we're gonna remove this, and we're just gonna say HWND. This is gonna be the app window is equal to that, basically. No need for this. And we're gonna have const here, I believe. And yeah, so I don't care about the width and the height, honestly. So I'm just gonna use the default, CWU's default. This is a constant that you could pass, and it would just use a default value. In fact, if you really wanna, you know, make some exact width and height, this is probably not the way you want it to do it, because this would actually define the width and height of the whole window. But you usually want to define the width and the height of the place in the window, or the area in the window that you can actually draw into. It's like your canvas, basically. It's called inner window, I guess. You have to use a Win32 function for that, but anyways. Cannot resolve symbol H instance. Where is that? Okay, here you go. Let's go with app H instance here. We could also say Lloyd module W, and then put in null ptr, I believe. Or is it Lloyd module handle? Lloyd. Yeah, this absolutely should work. I don't. What? Null ptr. Weird. Anyways, this is fine for now. Okay, so what's up now? Here, the window procedure that we're gonna define in a second. Currently, we're just setting it to the default. The window class, we really do not care. We could just pass it as the app window title. This is basically used for when you're just using Win32 only for UI. So like you could have like a window class for, let's say, a message dialog or a message box, right? And another window class for your radio buttons, and another window class. So like the window class is like the behavior of a certain type of window, kind of. So like every window class have its own window procedure that I'm gonna define in a second. Currently I'm setting it to the default. And depending on this procedure, the window will, you know, like behave differently. But this is not, you know, something that we need to care about since we're making our own rendering. We're not going to be using that crazy stuff. Okay, so cannot resolve symbol H instance. Let's go to app H instance here. LP param. As you can see, Win32 and Vulkan is very verbose. That's why I really recommend looking up for some AI or something that could help you with that, with the boilerplate. But yeah. All right. So anyways, so what to do? This is the cursor, by the way. It's currently set to IDC arrow, but you can change it to whatever you want, like hand, help, to some cross, I-beam. I-beam is what you get for like this, like the one that I have in my cursor right now. It's an I-beam. But anyways, this is the HBR background. I really do not care about this since we're going to be rendering ourselves. But this basically, you could use this to make a white color, red color, or something like that. Hold on, red brush. Let's see. What? No. There's some way to do it using getStock, I believe, or some weird stuff like that. Do not remember, honestly. It doesn't seem like it wants to generate that for me. Anyways, whatever. Let's just remove it. We don't really need it because we're going to be rendering ourselves. In any way, so now we could remove this craziness. We're going to create an app like this. We're going to pass in the H instance from our main function to this struct, and we're going to create a window, and we're going to pass it the app pointer, or yeah, there you go. Now we're going to show the window. I'm going to show the window after we have set up the renderer and everything. So like we don't show the user just an empty window, then after like let's say some seconds, then the window start rendering, which is quite bad. You know, show the window only when you're ready to render. But yeah, show window and CMD show, and here instead of this, just gonna say show window app, right? And we're gonna pass in the NCMD show here. Okay, and this is the main loop pretty much. We're gonna create a void main loop const app. There you go. We're gonna return, well, it's not gonna be void, it's gonna be message.wparam. What is that? This is wparam. Okay, and let's just return main loop. We're not gonna have any deinitialization code. We're just gonna let the operating system do what it can do best. When we close the application, it would clean up after us. So no need to waste the user's time there. And that's what's nice about being explicit, like in the C language, instead of using RAI. You could actually control when you want to destroy stuff. Like you don't need to destroy stuff every time. Only destroy it when you actually, let's say, want to recreate it or something like that. But like if you're just gonna end the application, you know, just end it immediately and the operating system could clean up in the background. Anyways, you also get a much cleaner code. But yeah, so right now what we should do, we got the main loop, we got the window. Now let's actually load our Vulkan library. Now there's a lot of ways to go about this. You could actually link it. Let me show you first of all the documentation actually. Hold on. Not the documentation, the tutorial actually. There's an interesting tutorial that you could follow through, because I'm not gonna explain all, like absolutely everything. Unless if you ask me for something particularly, if you ask me some question in the chat, I'm gonna answer it for sure. But yeah, go to this tutorial right here. It's the new tutorial. It's inspired by or based on Vulkan tutorial by Alexander Overvoord, I think. And this is basically the new Vulkan documentation. This is very new. I have just, well, not just, but yeah, it's still being worked on, right? Anyways, this is the link. It's in the chat. But yeah, you could read through this. I really recommend you read through this whole thing if you're interested. But in anyways, what I wanted to show you, I even forgot right now. Visual layout, bruh, I forgot what I was wanting to do. Oh yeah, I wanted to show you the part about the loiters. Yeah, I'm not sure I've seen that actually here, first of all. Is it here? I guess it's in the documentation. Yeah, it's probably in the other, not spec. There's the spec, which basically have everything you may need about Vulkan. But it's a bit advanced. I think it was maybe in the Vulkan guide. Possibly. Let me see if I can find it. What is yeah, hold on, using Vulkan loiter. Yeah, there you go. Okay, there you go. That's what I'm talking about. So there's also this guide right here. So our first job right now is to actually load Vulkan, the Vulkan driver, right? The Vulkan implementation. So Vulkan is basically an API. It's an interface. How I like to think about APIs, you know, like when you have a USB, you have an USB in your computer, right? You have a port where you put the USB in, right? So that port, USB-C or USB, I don't know, 3 or USB 2, whatever, basically USB-C or micro USB or whatever. So basically there's multiple types of ports. Now that type of port is like an API, right? And then on one side you have the implementation of that API, like the actual code that runs from the API, and the code that calls into the API, that hooks into the API, which is our application. So the one that uses the API, right? So we don't care about the implementation. So the implementation will be different. Like if you have an NVIDIA GPU, the implementation will be an NVIDIA driver for Vulkan for that specific device or whatever, right? So as you can see here, there's a Vulkan ICD. This is basically the driver, right? And there's the physical device. These are your GPUs or even your integrated CPU or whatever. Anything that could render using Vulkan or that have a Vulkan implementation. Right, so here the Vulkan loiter that manages these ICDs. Oh, well, not manages, but basically here as Vulkan application, this is us, right? So one Vulkan application, the second one, third one, whatever. So we load the Vulkan loiter from the system, either as a dynamic library or directly linking at compile time. This requires having a built Vulkan loiter, either a static or dynamic library that your build system can find. Build systems have documentation how to link to the library. Try searching insert build system link to external library online. So you can directly link it at compile time, but the problem with this is that your application wouldn't even run if Vulkan is not on the system. So you would get the popular Vulkan-1.dll not found. Like if the system doesn't have the driver, like doesn't have the dynamic library, or otherwise what we could do. So basically you don't have any control because your application wouldn't run if Vulkan doesn't exist. But you could also indirectly link at runtime using dynamic symbol lookup, using DL-SYM and DL-open in Linux. And on Windows, we're going to use some other functions that you're going to see in a second. And we basically load the library at runtime. And if there is an error, then we can actually handle the error ourselves. This is the first thing. The second thing, the good thing about indirectly linking at runtime with Vulkan is performance. So we could actually load the specific functions that we want, and then we could like call into the driver directly instead of every time going through the loader, then to the driver. But either way, you're gonna see how it is. It's not that hard actually. I think that's it for now. Let's just get into business, I think. Let's just get into business. Let's see. Okay, so here we could load the Vulkan driver library. Load the Vulkan library using the Win32 API, of course. On Linux, as you've seen there, you could use DLSYM and DLOpen. Otherwise, if you want to use libraries, you could use Vulk. It's an open source implementation of MetaLoader to simplify this process. But I don't really need that. Load Vulkan library. Okay, the AI already generates some code for us. App, okay, each module Vulkan library equal to Lloyd library W. This is the equivalent of DLOpen in Linux. Lloyd library W. You could either use the Unicode version or the ASCII version. Here I'm using the Unicode version by the suffix W instead of A. And of course I need to add this L prefix to the string to make it Unicode. So vulkan-1.dll. There you go. This is the name in Windows. If you're on Linux, you're gonna need to use another name. I don't remember exactly what was the name actually, but maybe it's gonna be something like vulkan.so or .1.so or something like that. I don't remember. Actually, it's gonna be libvulkan maybe or something. Anyways, whatever. So depending on the platform, it's gonna be a different name and stuff, and a different function to load it, etc. Unless if you use a library. So if Vulkan library equal null PTR. Now here, as you can notice, you can actually like basically choose what to do when the Vulkan driver is not on the system, or at least we have failed to actually load the loader. Here we're actually loading the loader, not the driver. Okay, so if Vulkan library equal null PTR, now you gotta say what you want to do here. Like some option could be, for example, if you don't find Vulkan, you could use, let's say, a software implementation renderer, right? Like you could use a renderer that runs in the CPU, or you could use OpenGL, or whatever other way you could use to render, right? Here we're just gonna, for now at least, we're gonna make a message box, and we're gonna say cannot find vulkan-1.dll. Please make sure to update your driver. Cannot find Vulkan-1.dll. Okay, great. So, and honestly, I don't like to do this way, because what happens when people get such error is that they would search Vulkan-1.dll on the internet and then download some malware, right, and put it into their system path. And boom. This is not the way you install DLLs. Let's just say cannot find Vulkan. Or your whatever. Anyways, so right now let's just say if Vulkan library equal. This is the only error I believe that we're gonna handle, because this is highly likely that it could happen. And we're gonna exit process, and we're gonna exit with status code 1 or whatever, doesn't matter. And yeah, that's basically it. Now we have loaded the Vulkan library, hopefully. Actually, no. What's happened? Window title Niclard. Oh yeah, I forgot. Let's see. Where is it? Where is it? There you go. Okay. So this should be app window title. Let's go. Well, what the heck? Assignment is read only. Oh yeah, my bad. I put the const in the wrong position, I believe. Maybe. In use parameter app in the main loop. Yeah, we don't actually need the app in the main loop really. Okay, and let's just remove it from here. Okay, let's go. Cannot find Vulkan. Please make sure to update. What? Are you kidding me? Lloyd library W. So what I've done wrong here? Interesting. Vulkan-1.dll. Yeah, that should work. Huh? Interesting. Oh, my bad. If not Vulkan library. Yeah, my bad. Right. But there you go. You've seen what's gonna happen when when we can't find the Vulkan library. So right now we have loaded that, I believe. But why we're not seeing anything though? Did I miss something again? Yeah, I probably missed something again. What I've done. Show window. Yeah. Maybe this is wrong. Yeah, the Win32 API is very weird, not gonna lie. And let's see. Maybe the width and the height constant isn't right. I mean, that happened for me once. CW's default, which is correct. So what's up with this? Why no window is showing up? What did I miss? App window title. Let's not load the Vulkan library. Could it be doing some problem for us? No. Interesting. Okay, so what's happening then? We're loading the Vulkan library. Then we're going into a main loop. Well, let me debug. Let me debug, see what's happening there. So I would guess we're loading the Vulkan library. Then we're creating a window. Great. And we're showing the window. And then we're going to the main loop. Okay. So what's up? Huh. And then we don't hear anything anymore. Oh, I guess. Interesting. Maybe we gotta change the window procedure already. Let's try. So let's create the window procedure. There you go. Switch WM destroy, and let's pass in, instead of def window proc, which is the default one, let's pass in this window procedure and let's see what's gonna happen. Or maybe I haven't initialized something by mistake. App window title, DW style, HWND parent. Yeah, this seems to be. There you go. Okay, so we're getting a window. Let's go. Maybe the problem was that I had to give it a window procedure now after changing something up there. But either way, so this callback macro, it's just std call. It's just like the Win API thing here. It's the same thing, just, you know, just a different macro for, you know, just for readability pretty much. But it's pretty much just std call, just the naming convention of Windows. And L result is just long. You know, Win32 macros are wild. Same thing with HWND and stuff, but anyways. So window procedure, we get the window, the message, it's an assigned int, and W param and L param. So now we switch on the message. This is basically what message type, right? So case WM destroy. So if we're gonna destroy the window, then we're gonna post quit message. Honestly, instead of WM destroy, you probably want to use close instead, maybe. Let me see. Yeah, go with because basically there's WM close and there's WM destroy. Yeah, honestly, let's just go with it anyways, never mind. It's been a min. Hello, Clousy, welcome to the stream. How is it going? So either way, you post a quit message and you give it the exit code, right, to actually close. Because if we don't do this, what's going to happen is that even after closing the window, the process will still be running. The main loop wouldn't quit, you know, so we have to quit the main loop and give it an exit code. And now that exit code would go to the W param of the message that we're getting here. So I didn't actually explain this, right? So basically here we have an MSG struct. It's just a struct with these things right here, right? And what happens, you call this get message W every time, and you give it a reference to a message. This is a mutable reference, right? Basically means that it would actually put some content there. It's not const. If you check this, it's not const. Well, it's a macro, which freaking sucks. But anyways, LP HWND null PTR. This is if you want to get like events for a particular window. We don't really need that here. We only have one window anyways. And even when you have multiple windows, unless if you want to filter to only get the events of one window, you really don't want to do this. This is the same thing, just filtering message types between the minimum and the maximum, but we don't need any of this stuff. Translate message, I don't even remember what this does, but either way you do it. I believe it was for translating some key code stuff or something like that. I don't remember, but it doesn't really matter, honestly. And here dispatch message W, which also do some crazy stuff. And here it basically dispatches the message and return message.w param. Here, after you post the quit message, right? This 0 right here, or whichever exit code you put here, would go to the message W param. And we're just going to return that. And yeah, that's basically it for that. And here, by the way, get message W would actually stop, like it would, what to call it? It would stop the thread. Well, not stop. It would suspend. Yeah, kind of would suspend the thread until we get a new message from the Win32 API, or from Windows basically. And once we get that, we dispatch the message and it would go ahead and call our window procedure, right? And so we do this stuff. But basically why this is the case, like in GFW or other Wind libraries, what you would do, like what you would usually do, you would actually do while, let's see, while not window should close or something like that. GFW window should close. GFW, yeah, something like that. And you would GFW pull events, right? And you would say, I guess, GFW swap buffers, right? If you're working with OpenGL, you would also use this. But either way, this is kind of, this is actually not the same. So here we're actually pulling. So every time we pull the events, so this is like a loop that never ends, right? It keeps every time check if there's new events, every time it never ends. But here, no, we just wait for the event to happen, which is more, you know, battery friendly, I guess. But it doesn't really matter. It's going to be the same outcome actually in our case, since we're going to be rendering every frame anyways. But yeah, but basically in some sense, pull events, when you call GFW pull events, it's probably doing, it's actually maybe using peak message W, because there's peak message W and get message W. You could use peak message W to do polling. This wouldn't suspend the thread. So this is what you would do if you don't want to suspend the thread. But if you want to suspend the thread until you get a new event or new message, then you use this one instead. But anyways, I'm just going to use get message W anyways, and I'm going to show you why in a second. So whatever. Alright, so this is really not important. This is just like boilerplate code, really. Just if you don't understand something, it's not a big deal here. So let's see. Case WM destroy. Yeah, so I think everything is good right now. What we need to do now. Yeah, I believe let's start with the Vulkan stuff, I guess. Yeah, sure. So after we loaded the Vulkan library, we need to create a Vulkan instance, which is like a handle. It's like like a key to the library for our own application, in some sense, I guess. Some token for our own application. Like every application usually would have one instance for Vulkan, basically. And the instance kind of just like have some configuration stuff and some extensions, etc., as you're gonna see in a second. But either way, we're gonna create the Vulkan instance after creating the library, after loading the Vulkan library. So create instance. Let's go void create instance. You can notice that using C is really not that hard. Like if you ask around, is it like easy to make a Vulkan application using and Win32 application using C? Everyone will say it's much harder than C++, but it's actually the opposite. I actually know C++, right? And I can program in it, but like I just hate it so much. There's just some broken stuff right there, and your program just gets very complex real quick. I love Rust, the Rust programming language, but I wouldn't particularly use it for this case because I want to use the Win32 API directly and the Vulkan C API directly. And while you can do that in Rust, it's not that great. Usually in Rust, you don't want to use unsafe APIs directly. You want to first of all go ahead and wrap it in a safe wrapper, in a safe library, and then use it, right? This is just how the library works, and it's pretty good. But sometimes I like to do some low-level stuff, so I go with C. There is Zig, which is going to be a perfect replacement for C in the future, but not currently. It's still not released. And yeah, it's just like it does have a lot of break-in changes, and LSP is trash, hot mess. But anyways, whatever. I'm fine with C for now. And also another thing, I love my designated initializers. Hold on. I love my designated initializers, which is something like this thing. So instead of like declaring the struct a variable, then passing a reference, you just pass a reference directly. This would seem to you like accessing freed memory or something like that, but it's actually not. This is going to be in the binary, I believe. Or like, not really, it's just going to be, the duration of this would be extended to the function call, I believe, or something like that. But either way, it's perfectly fine. But whatever. Enough rants. Let's go create an instance right now. So app const app. Also, we could actually make this const and this const. Okay, const. Now in Rust, by default, every variable is constant, and then if you want something to be mutable, you have to make it explicitly mutable. But in C and C++, somehow it is the opposite. You have, like, everything is mutable by default. Everything is dangerous by default, and then if you want something much safer, like const, then you have to opt in. Anyways, so let's create the instance. And let's go ahead and, but before we can create the instance, we don't have any Vulkan functions. And before we even get the Vulkan functions, we don't have any Vulkan headers. I mean, the first thing though, you have to actually install the Vulkan SDK. Now, you don't really need this. You don't explicitly need this, but we're gonna need it for later on for the compilers and some other tools for helping with the development of Vulkan. Like the Vulkan configurator, but we're gonna see in a second about that. Either way, if you want to install the Vulkan SDK, you could, just look it up. There you go. Download the Vulkan SDK, choose the platform, and yeah, it's that simple, pretty much. And you install it. In either way, so yeah. Well, first of all, let's include Vulkan. But in my case, for whatever reason, by default in this IDE, it can't find my Vulkan SDK Vulkan headers. I don't know why exactly that's the case. It should find it, but it doesn't. Either way, this is not a good way to go about it, to actually depend on the Vulkan SDK being in the system, because it's not always the case. So what we're gonna do, we're gonna use CMake to actually download the Vulkan headers repo, so we don't depend on the Vulkan SDK being in the system. Vulkan headers. Well, hold on a second. There you go. So this repo contains the Vulkan headers, so you don't need Vulkan SDK. As you can see, Vulkan headers are shipped as part of the official Vulkan SDK, but at least personally, I don't like to depend on the SDK, so let's go ahead and download this. I'm going to copy the link. I'm going to include fetch content. If you want, you could also use CPM, but I'm just going to use fetch contents, honestly. And fetch content declare. I'm going to go with GitHub URL, well, not SDL. I'm going to go with Vulkan headers. Vulkan headers, get repository, paste in the link, and paste in some git tag. Here you could put in the version or the git tag, which is the latest one is this guy. So you could go with whichever version of the headers you want, as long as, like, if you're going to be using 1.3, you could just go with 1.3.0 maybe or something. Either way, whichever. Let's go with, anyway, fetch content declare and fetch content to make available Vulkan headers. And finally, we're going to link it. Notice that the AI actually suggests us some like old way of using CMake. I hate this way of using CMake. The modern way is to actually, as long as the library uses a modern CMake, you could say target link libraries Vulkan headers, just like that. Private project name Vulkan . Let's see if this works. And this should go ahead, as long as you have GitHub, like Git in your system. You should have Git in your system as a developer for sure. It's gonna go ahead, clone Vulkan headers, and then include it into your project. Okay, so let's see, I guess it's Vulkan. Yeah, right now, as you can see, we have it right now. Great, it's as simple as that. But before we include Vulkan, we need some macros to define to tell Vulkan how we want to work. First of all, vk no prototypes. We're not gonna be linking the library at compile time, or like at link time actually. Not compile time, yeah, link time. We're gonna be linking it dynamically, so we do not need the function declarations. We only need the function pointer types, like the arguments, signatures, and stuff like that. So I'm gonna say to Vulkan to not include those functions declarations, only include the types of the functions. So vk no prototypes. The other thing that we're gonna do, since I'm using Win32 directly, I'm gonna define vk use platform Win32 khr. Of course, you gotta make sure to use this to define this before including the header of Vulkan. And same thing with Windows, you gotta define this before including the Windows header, right? So what I'd like to do to make sure that doesn't happen, because even my own formatter actually reorders these includes in alphabetic order, I believe, maybe. So I like to always put the defines first and then the headers. But anyways, so that should be good to go. Now create instance. So right now I think we have the Vulkan library. Oh yeah, I forgot to actually put it inside the struct. So let's do that. H module Vulkan library, and here let's just say app Vulkan library. Let's go. Yeah. Now basically you could put const in two places. You could put it here and you could put it here. Now when you put it here, this is gonna make the pointer variable itself the pointer variable. So you could change this to point to something else, right? This specific variable, you can change it to point to something else. If it's not constant, right? But if you do the const like this, then you can basically, what that means is that you cannot mutate anything you cannot, what should I say? You cannot set to the pointer directly, I guess. I don't understand, like I don't know how to describe it. But basically it's gonna be read only. But you could do both. But in our case, we need this way of doing it. Alright, so that's basically it for that. Now let's create the instance. First of all, we need to load the function that are gonna help us load the other Vulkan functions. So how are we gonna do that? Autoconst vk get proc addr. This is what it's called. And you just call get proc addr, which is a Win32 function. And this Win32 function, you give it the handle to the library that you loaded. As you can see, we have loaded it here. And then we give it the name of that function that we want to load. So in this case, vk get instance proc addr. And then, of course, after that, we cast it. We cast it to the type of the function that we want. Now here, this declaration is inside the Vulkan headers. Look at that, pfn vk void function vk api blah blah. As you can see, this is the signature and stuff. This is basically the type of the function. So we cast it to that, and now we could basically use it however we want. Vk get proc addr. Now this could fail. If you're paranoid about that, you could like say if vk get proc addr blah blah. But honestly, in practice, this rarely fails. Like a lot of things rarely fails, but it could fail. So I'm not gonna bother with that to keep things very simple. So vk get proc. Now we could use that to load the other Vulkan functions. So vk create instance. Well, autoconst. There you go. vk get proc addr. Now instead of using get proc address, now we could have used get proc address directly, but how the API is designed, that you only use the system specific or the platform specific function, which is in this case get proc address, only once to get this guy, right? And after that, you only use this guy in a kind of like a cross-platform way, right? So, but either way, we're going to be using that. vk get instance proc addr. There you go. And this is the vk create instance. Like this. All right. Here you pass it the instance. But this specific function, vk create instance, is a global function, which doesn't need an instance, right? It's not part of instance, it's global. And I mean, you need that. I mean, it's the one that actually is going to create the instance for us. So let's actually use now vk create instance. Now you're going to notice that every single Vulkan function, what it does return, it returns a vk result, which is like tells you if the function failed or not, and if it failed, how, like why, right? But I'm not going to care about errors. I'm going to handle errors only at debug time. Now, if you see Vulkan tutorials, they would actually tell you to enable validation layers programmatically. You gotta write a bunch of code to enable that to yourself in the code. But we really do not need that. As long as you have the Vulkan SDK, you could look for the Vulkan configurator. This is included in the SDK. Also, you have a Vulkan cube, which you could use to make sure that Vulkan is running on your system, is working on your system, right? And this is the Vulkan configurator. So you're gonna make, instead of layers fully controlled by the Vulkan applications, you could actually click on this, overriding layers by the Vulkan configurator. And now here you could select the layer. I'm not sure if there is some description for it in the guide. Let me see. Where's the guide? I'm not sure if they did include something about it here. I mean, yeah, there is Vulkan layer, but this is not a good way to describe it actually. There's another one, I believe. That's a bit better, but there is a better one. Okay, there you go. Let's go. So this is the way it works, right? So let's say you have linked the library directly, the loader directly into your system. Now, into your application, sorry. Now what you're gonna do, every time you call Vulkan function, what's gonna happen, you're gonna go through the loader trampoline, then you're gonna go through all the enabled layers, right, one by one. So you call this one, then this one calls this one, and then this one calls this one, and so on, until you reach the driver in this call chain, right? Now, if there's no enabled layers, of course, you're just gonna go from the loader trampoline to the loader terminator, and then to the driver. Now, when you load the functions, the device functions directly, what's gonna happen, which we're gonna do in a second, after we create our device, what's going to happen is that the loader at that point will know the driver, so we could basically get the Vulkan functions directly to the driver. So we could call, instead of going through this whole call chain, we can call directly to the driver instead, which is going to be much more performant. Why we do need this loader trampoline, loader terminator? Well, too simply because there's a lot of Vulkan implementations in our system. Like if you have multiple GPUs or in general multiple physical devices that supports Vulkan, you're gonna have multiple drivers, and we do not know which driver exactly you want. So depending on your stuff, the loader will have to figure out which driver you're talking about and which device you're talking about, etc., etc. And then, you know, defer you to that thing that you need, which is going to take some time and take some performance, you know. So that's why we do that, so we could call directly to the driver, hopefully. So yeah, pretty much. So now let's go ahead and call the Vacay create instance after loading it from the library. And here you're just passing the Vacay instance create. Now you're going to notice here in Vulkan that you pass everything as like instead of arguments, you pass in a struct, and that struct is filled with arguments, and every struct have its own s-type, Vacay structure type instance create info, and this would basically is an enum that holds the type of the struct of the parameters, right, which is Vacay instance create info, right? So why this is the case? Because basically there is something called pnext. Now some people would actually tell you that the Vulkan is a C API, so it doesn't know the type of your struct and stuff like that, which is wrong and correct at the same time, but mostly wrong, right? So why it's wrong? Because this is not used, the API actually knows the type, right? But the thing is, when it's not going to know the type is on the pnext. So there's something called pnext, which as a beginner you're not going to use, at least for now, which you could basically use to you know, chain structs together like a linked list. Yeah, this is basically a linked list, not like a linked, it's actually a linked list. Right? So you can give a reference to another struct of parameters. Like here, for example, vkdebug utils messenger create info exe, which you're going to actually use if you want to do the validation layers by code, which we're not going to do because we have the Vulkan configurator. Right. So the thing about this is that pnext will be a void pointer, and a void pointer, we cannot really know the type. And like this struct could be anything. It could be any type, because you can actually chain multiple types of structs. You never know. So it's going to use this S type, this first field in the struct to know the type, basically. That's why we have S type on every struct. Okay, so application info. P application info. Now we don't need to actually give it all this. And by the way, I didn't mention something about designated initializers. Is the fact that if you provide something, like if you actually don't provide something, then it's going to set it to 0. It's not going to be initialized. It's actually going to be 0 or null, depending on its type. So so the things, like mostly when you have some default enum or something, you make it 0. So here in the designated initializers, you don't have to actually mention it. So yeah, I actually do not care about the H cursor, so I may as well also remove it, but anyways, whatever. So here, the engine version is not really required. In fact, the application info, the whole thing is not required. It's optional. But I'd like to actually give an API version, so I'm going to leave this. I'm going to actually use the latest Vulkan version, which is 1.3. I mean, you could use the first version or whichever, but I'm going to use the latest. So engine version, engine name, application version, application name. This is optional, pretty much, so I'm not going to provide it, honestly. Just the names, doesn't really matter, and the versions. And here, let's see, enable extension count. Okay, enabled layer names. There you go. This is how you actually enable layers programmatically. But I'm not gonna go about that because we have the Vulkan configurator, which is much nicer. So enabled extension count. I'm gonna enable 2 extensions, and so basically by default, Vulkan, you could use it without a window. Like you could just use it, for example, for compute, and at that point you may not need any extensions at all, right? But since we need to render to a window, we need some extensions. We need vkhr surface, and then we need a platform specific extension for that surface. So again, this is like the API kind of in terms of Vulkan, and then the implementation. So like the Win32 implementation of surface, basically, kind of. But either way, so enable extension count 2 extensions, and then here we provide them. There you go. And look how clean is designated initializers instead of that mess. It's much cleaner and much easier to read what's going on. So instead of going through enabled extension names, and you're going to find here a variable name, and then you have to jump to that variable and then read that, it's all inside one thing, one statement, which is great. Now here you would usually just say if vk create instance not equal to vk success, you know, then handle the error depending on what that error is. Like there's multiple errors. You could find the errors in the API spec. There you go. This is a lot of errors depending on the function. You can find the possible errors in the spec, and there's also warnings even. Warnings are positive values, errors are negative values, and vk success is 0. So actually instead of that, you could just say this. So if this, then that means you have a failure. This failed. Honestly, I'm not gonna bother with that because like the instance would usually not fail as long as you don't do some programmatic error. I mean, it can fail, but it usually doesn't. So I'm not gonna bother with that, honestly. And for debugging purposes, I have Vulkan configurator, which I'm gonna set the layer as validation. So here I'm gonna put basically a layer between my driver and my application in the call chain, and this would basically intercept my calls to the driver, and it would actually analyze those calls and check if there's any weird ways we're using the API or some, but basically that, right? So as you can see, there's a lot of cool stuff that you can set here. You could do all of this programmatically, but it's going to be a huge mess. So this is a way better, and if you want to disable all layers, you could just do this. There you go. You could change the layer to something else like synchronization, portability, frame capture, API dump. Validation would validate, make sure your calls are sane, you're using the API correctly. API dump would actually show you the calls and their parameters and their return codes, etc. You're gonna see all of this actually, but generally you could put keep this as the default values. Other than this break, make sure to put this on. So when you're running a debugger and an error happens, some function errors, it would automatically break into that function that errored. You don't have to handle errors yourself. So yeah, there you go. Thank me later. Anyways, so debug output. Log a text message using blah blah. Whatever. Here you could set the message severity that you want to show. You can set info, warning, performance, and error. You could do this. Now let's see what we got. Cast between incompatible function types or from far proc. This is very annoying error, but you could just warning. You could just actually ignore this, and we could just ignore it like this. So -w no dash error equal cast function type. We have to reinterpret this function that type as this type, because that's how Win32 works. And this is how you can reinterpret a function. There's no other way that I know of. So let's go. And we got a signal trap. And where that happened? In create instance. There you go. It happened here in vacate create instance. So it braked here. Why? Well, we got a message from the devalidation layer. It's saying this gibberish. And you could just ignore this. I don't honestly even know why this is the case, but every time it just makes this at first, and it's just a status message, nothing crazy, just an info, nothing serious. So if you want to ignore a warning, you could just copy this in, right? Come here, mute message VUIDs, and paste the message ID there, and there you go. You could also toggle it on and off. And let's go. Now just go ahead and run it again. And there you go. You're back into business. Great. So since it didn't break into our code, that means we had vacate create instance was successful. We don't even have to check. The validation layer would check for us. There's also the API dump layer, which you could actually run. And you're going to see the actual calls that you're making to the API. And this is very useful actually, at least for me personally. I find it very useful. I really wish more APIs had such a amazing debugging experience. But there you go, vacate create instance. Here you can see the frame that happened, which thread, and what it returned, what that call returned, what you called vacate create instance. It returned vacate success. Right, and this is the address of the struct, the S type, there you go, the pnext, null, flags. Notice that we didn't set pnext here, so it is initialized as null. Flags, we didn't set it here, so it is initialized as 0 because we use designated initializers. And the application info struct, pnext again, application name, blah blah. API version, it is set to this thing. Okay, and the enable layer count, blah blah, but you got the point, right? So here's the extensions also. Pretty cool. So that's great. That's a very amazing tool that most tutorials don't show you at first, but I like to actually, in fact, we're going to be using it actively, because we're not doing any error handling in the code itself. At least, like, I'm only gonna handle the errors personally if I know that this function can actually, like, let's say loading a file, then yeah, that could really fail if that file doesn't exist, for example, or it doesn't have perfect, like, correct permissions, right? Then I would like to handle that error. But like, if it's something that, yes, it could fail, but practically doesn't, or at least usually doesn't, I don't really care, honestly. I mean, what can happen even anyways? It would just crash, it would misbehave, then you could just restart the application. Unless, of course, if you have an application that is connected to the internet and that security comes into business and safety critical systems and such, then yeah, that becomes a little bit of a problem. But then at that point you have a bigger problem. Either way, this is not our case, so who cares? Vk create instance. Now what's next? We have created the instance. As you can see, we just declared to the API or to the driver which version we'd like to use of the API, how much which extensions we want to use, and yeah, there you go. Okay, so what's next now? Also, we have an allocator here, which you could just pass in as null PTR. Basically, here you could give some custom functions for the API to so we can use it to allocate. So instead of using malloc, realloc, calloc, and stuff, it could use the function that you passed in as a struct. But I'm not going to use it, and I would recommend not to, because usually the driver could do a better way of allocating itself. You don't really need to give it custom allocation functions, unless, of course, let's say you have some actual use case for that. But anyways, so vk instance. All right, so this is also another pattern that you would usually notice in the API. It would have a p allocator argument, and at the end it would have a out parameter, a mutable reference or mutable pointer to the thing, right? So it would return for you the error, right, that you could check and stuff, and then it would give you the actual result returned object or value, right, in a variable, through a reference, mutable reference. All right, so let's actually make a vk instance here. There you go, and we could just pass in a pointer to it. There you go, great. Now we have created our instance. In fact, instead of doing it like this, let's just store it here, vk instance, yeah, there you go. And let's just come here, say app instance, and let's go. What's happening? What? Did I make some mistake? Huh? What is going on? Oh, is it? Yeah, okay. I see. All right, let's go. So vk create instance. Now we have created instance. Now what's next? What's next is we need to choose a physical device. So we need to choose, like, you could have multiple GPUs on the system or an integrated CPU and so on. So let's choose one device. I'm just going to choose the first one, which is usually the best. It's usually selected by the operating system, you know, depending on the user preference or depending on the battery usage and stuff, like the battery mode and like the energy mode and stuff. Anyways, I'm just going to use the first one anyway. You could actually get the properties of the physical instances and choose depending on that, but I'm not going to go that insane. I'm just going to keep it simple. Just going to take the first one. So here's how to do it. First of all, we need a function that is called vk, I think a physical device, no, enumerate, sorry, enumerate physical devices, I believe. There you go. Let's go. That's it. And vk enumerate physical devices. And here you could give it the how much instances you want to enumerate. I'm just going to get the first one. and I'm gonna pass in here where I want to put that physical device. I'm gonna put it here. Or honestly, yeah, fine. Let's put it in the app. Right, and let's go here. Put a physical device there. Let's go down, and in fact, instead of putting it here, I'm gonna create a new function. Let's call it pick a physical device. Void pick physical device. There you go. Cool. And let's just get this function here and use it here. Now the problem, we're not gonna have Vicky get instance proc ADDR. It doesn't matter, we could just get it again, but like yeah, let's just do it again. Let's load it again, who cares? Or yeah, I think it's fine for now. We could later on maybe put it into a variable and reuse it, but it's fine. What really matters actually is not this code. What really matters is what you do inside the loop. That's what really needs the performance. But either way, whichever. Vacate and emerge physical devices. Again, this could fail, but I'm not gonna care. And also, you could actually get how much devices by just giving it here, null PTR, and then here give it a reference to some integer, actually Win32t. Like basically, you gotta do it like this, right? So physical Win32t physical device count. And this is another pattern that you're gonna see in the API a lot. You're gonna do it like this. Yeah, you just, so basically if you pass the second parameter as null PTR instead of the place where you want to put the actual contents of the array, what's gonna happen is that it would actually populate the variable that you gave it in the reference that you give it in the second variable with the actual count of the array. How big is the array? Right, so because like C doesn't have the concept of array, like it basically just gives you a pointer, but you do not know what that pointer points to. Is it an array or is it just one item, or what exactly? So this pattern is being used, but in my case I only care about the first one, so I'm just going to do it this way. So there you go. Okay, so after picking a physical device, now what? We're gonna go ahead and create a device out of it. So this is like the physical device. Now we gotta create a logical device, like an interface to this physical device that we could, use this device from. You could make multiple logical devices from one physical device. Or like if you even kind of think about it, like you have one GPU, but like multiple applications that uses Vulkan have multiple representations of that single physical device. So you kind of have a logical device there. But either way, whichever. There's also another thing, which is that you could use multiple physical devices in one logical device using an extension called device groups and such. But you don't have to care about that. That's very advanced. Like basically that you would use that if you want to use multiple GPUs using one device in Vulkan, though there is some restrictions there. And first of all, you shouldn't be broke. You have to have multiple GPUs, which I don't, right? So, and those GPUs should be very similar, if not the same, in terms of their capabilities, I believe. Well, whatever. I never really used it, honestly. I just have some information about it. So either way, let's actually get the device and now let's create the device. So after picking a physical device, let's create the device. We see we have missed a step. but we're gonna come to that in a second. Though if you have checked the tutorial, you're gonna find some more proper way of doing this, I guess. You know, checking stuff, making sure stuff is compatible, etc. But in practice, this is usually enough. But yeah, you could check the tutorial, honestly, the written tutorial that I've linked in the chat. So create device, but in practice, this is more than enough, usually. So create device. Okay. VK create device. So here what we got the instance procKDDR, and to be honest with you, this is kind of silly. Let me just load like after loading the Vulkan library, I'm just gonna load the instance procKDDR, honestly. So let's go ahead and do that. So after loading the library, we're gonna do this app. Just copy this. Is equal to that. And now let's add that here. OBS disconnecting. What's up? Okay, I have reconnected. Is everything good, guys? Let me know if the stream is fine. Seems to have reconnected for some reason. Either way, so we got the instance procKDDR, great. So after loading the library, we're just gonna take that. We're gonna load it from the library, VK instance procKDDR, and yeah, there you go. So now we don't need to load it every time. We're just gonna say app. Yeah, app VK get instance procKDDR. There you go. Null PTR, VK instance, great. Same thing here. There you go. And for the device, well, actually, instead of doing this, now that we got the instance, instead of doing this, what we could do actually, we can, yeah, we actually should give it the instance, right? And we did, yeah, we did. Here, since it's a global function, we give it null PTR. But here, after we got the instance, let's give it that. And this particular function is an instance function. And here, create device. We don't need this anymore. And this, we're gonna get VK create device, which is also an instance function. That's why we use this with the instance. And let's go. So here we passed the S type as always. So the enabled features, I'm not gonna enable any features. So I could just keep this empty. It's gonna set it to null. And enable extension count equal to 1. Yep, I need that. PP enabled extension names. And here we give it the array pointer. How much extensions, and here the extensions. Instead of using a string, I'm gonna use a actual constant for the string, which is less error prone. You know, you could easily mess up the string, the text, which is not gonna, you know, make a compile error. Anyways, queue create info count 1. I'm gonna request 1 queue. You could go wild with Vulkan queues for multi-threading. So like if you want to use your render from multiple threads, then you may be, you know, interested into using multiple queues, but it's insane. You gotta be a little bit more advanced because you gotta do the synchronization yourself and stuff. Either way, for now, we're just gonna use 1 queue. I'm just gonna go with the first queue. So queue family index 0, the first queue family, sorry. And if you want to check that out, I don't think I have the Vulkan caps viewer. Yeah, I haven't installed it in the system. Let me install it. So there's another interesting tool that I'm going to show you. Vulkan caps viewer by Sasha Willems. Let's go Doloid, Windows 64-bit. Okay. Show in folder. Alright. I have to go now, but thanks for explaining Vulkan. I have to go. C++. Goodbye, Oscar Smith Jones. Thank you for tuning in. See you later. Extract all. Okay. Vulkan Caps Viewer. More info. Run anyways. Let's go. Okay, so once you install this and you run it, you're gonna find all this cool stuff. So this is basically like you would select a physical device here. In my case, I have only one physical device, right? And here you could see all the properties of this device. Let's go. A lot of cool stuff here. Like the device type, discrete GPU, the device name, NVIDIA GeForce GTX 1650, driver version, the API version 1.3.271, buffer image granularity, blah blah, whatever. This is the core 1.3. This is the features and the other properties that is in the 1.3 version, and then the extension stuff. Okay, pretty cool. Now the features that is available to your physical device, or that are available, and here the extensions also, and the formats, the key families, the memory, the surface, profiles, instance, blah blah blah. But what we care about right now is key families. I don't know how to make this dark theme, but either way. So graphics bit, so we have multiple queues here in my case. So this would be different depending on the physical device, but in my case I have 5 key families, interestingly, right? So I have the first one, which supports graphics, compute, transfer, and sparse binding, and it contains 16 queues, right? And the second queue, transfer only, with 2 queues. Third, compute with transfer, 8 queues. Fourth, right? Transfer, decode, video decode bit. Actually, you could use Vulkan to decode video right now. 1 queue. And finally, the last queue is video encode. You could use this queue to encode video using Vulkan, using the GPU, which is wild. Queue count 1. And also if it supports presentation or not, if it supports presentation to a window or not. These ones of course don't. This one does. Okay. This one don't, and this one does. But usually the thing is, the first key family usually is the one that supports that is the most versatile. Like it supports everything. Like this one, the first one is supports graphics, compute, and transfer. Okay, well, not everything, but like most that you're gonna be interested in. Graphics and compute mostly, and transfer. So yeah, and it supports presentation. This is not like necessarily the case according to the spec, but it's usually the case, so I don't care. So yeah, pretty much. So we're not gonna care about this right now. I'm just gonna go with the first queue family with the first queue, 1 queue, which is what I'm doing here. I'm only requesting 1 single queue, and that 1 single queue would be queue family index 0, the first queue family. And since it's the first queue family equal to 0, I don't have to actually specify it since it's 0. Queue count 1, queue priorities. This is also so basically every queue that you requested. In my case, I requested 1 queue, so I gotta give it 1 priority. But this doesn't matter in my case since I have only 1 queue. So, but if you had multiple queues, you could set this to prioritize 1 queue over the other. But yeah, either way. So that's pretty much it to create the device. Next up, what we should do So we got the device up and running. Now we have a logical device. Let's go. Let's go. So, so what we need next. Let's see if this works first of all without any problems. Great. Now one last step to, well, to kind of end the initial initialization. We're not even close to rendering something. That's how verbose is Vulkan. We're just starting out. Anyways, let's go ahead and yeah, we need the surface. Before even picking a physical device, we need the surface. Now, if you want to set this up properly, you would basically create an instance, then create the surface. Well, of course, after creating the window, you would create the surface and then pick a physical device that is compatible with this surface. In my case, I don't really care about that. I'm just gonna pick the first physical devices I've done, and here let's create the surface. But either way, this is the order that you would want to go with. Create the basically load the Vulkan library, create the instance, create the window, create the surface, pick physical device, create device. And then finally, after you're done, you're ready to start rendering loop, you show the window. So create surface. Now what we got here, create Win32. Okay, so the AI already done some crazy stuff for us. Let's see what it did. VK instance proc ADDR. Now this is wrong. I mean, it would probably work, but it's not the best to go about it. Now that we got the device, we know which driver we want, right? So now we could use the device to load the function directly. So instead of vk instance proc ADDR, we could actually use vk get device proc ADDR, but we don't have that yet. We have to load it actually. So maybe not the fault of the AI. Let's see. So after loading the device, just like what we have done with the, after we have made the instance, right? Well, actually, we didn't do that, interestingly. Actually, yeah, it's, I mean, it's using the same function, right? So, my bad. Either way, so we have another function, pfn vk get, or actually, yeah, get device proc ADDR, right? So instead of get instance proc ADDR, you get device proc ADDR. And let's load this after creating the device. Or is it after creating the device? No, actually before creating the device. So I believe we could probably do that after creating the instance. So create instance, where is it? There you go. And what we got here, why we're, oh, never mind, gotcha. Okay, so after creating the instance, what we're gonna do, we're gonna say app vk get device proc ADDR, we're gonna load it, and we're gonna give it the instance, and there you go. That's how you load it. Great. Now we could actually use it. So where is it? Create device. Now if I had, by the way, the error handling, it's gonna be like if conditions all over the place, or at least a macro and such. Now without error handling, this is much cleaner and much easier to read and stuff, but yeah. Alright, so what's up now? We created a device. What's next? What I'm doing? Oh, actually the surface, we have to use the instance for that. We're not gonna use the device just yet. So for the surface, we're gonna load. Yeah, so actually the AI was correct all along. Let's go. Okay, so never mind. Let's go ahead. My bad. So we give it the instance, right? And then since we're using Win32, we have to use this Win32 function. Now, if you didn't define this macro, you wouldn't have this platform specific function. So make sure to define it before the header. And what else? So now that we got that out of the way, here this is going to give us the instance app surface. Sorry, the surface, yeah. So let's actually create this field. Let's go. And the order doesn't really matter, but I just like to be a bit organized here. So maybe before the physical device, right? And let's go. So, and you basically give it the H instance of your application, you give it the window handle. That's basically it. So for every window you create a surface. And yeah, pretty much as simple as that. And yeah, now I think we can create the device, I believe. Sorry, the swap chain. Let's make sure that there's no errors so far. Yep, seems like it. Great. So let's create the swap chain now. And finally, we got to use our device that we've just created. So let's use it. Void create a swap chain. Well, the thing is about create swap chain is quite interesting, because unlike the other functions, which we're going to call only once for the whole application lifetime, this one we're going to call multiple times. Because every time the swap chain gets resized, we have to recreate it. Like basically every time the window gets resized, we have to recreate the swap chain and all of the resources that depends on that swap chain. So I'm gonna call it instead configure swap chain, honestly, instead of create, because it's gonna either create or recreate the swap chain. Though you could call it whichever you want, doesn't matter. Just being picky here. Okay, cool. Now there's a lot of crazy setup that you could do. You could make this as complex as you want, but I'm gonna make it as simple as possible again. So what we're gonna do, we're gonna load first of all vk get physical. As you can notice here, that is some crazy stuff. I only need the first line, I guess. Yeah, I only need the first line. And here we're gonna load this function vk get physical device surface capabilities khr. You would notice khr suffix here because this is part of the surface extension, which is made by the khr group, right? So that's why it's there. Like for example, if the extension is made by NVIDIA, it would be NV here, NV suffix or whatever. If it's a core function, it wouldn't have any suffix basically. And some extensions gets promoted to core in the next version and stuff. So like for example, like let's say some function in extension whatever x, right, gets promoted to core in the next version. What's gonna happen? The suffix gets removed in the next version, basically. But anyways. So now we can use this function, and this is by the way an instance function. So we use get instance proc_ddr for it, and we pass the instance to that. So what we should do here, this would give us the surface capabilities of the surface. It's pretty self-explanatory. The same pattern, you give the here you give the physical device, the surface, and then it gives you back the surface capabilities in a pointer. So yeah, vk surface capabilities, and there you go. Now you could do some crazy other stuff, but I'm not gonna do that. This is usually enough for my case. And I'm also gonna load a function that would help me create the actual swap chain now. So create swap chain khr. Let's go vk create swap chain khr, and there you go. As you can see, a lot of boilerplate, and the AI is just the best at that. At least in C. So vk create swap chain khr, we give it a device. The only downside to using AI when it comes to such things is that sometimes it can miss something, and basically you have that overhead of constantly having to check for if the AI generated correct code, so you still have to skim through it just to make sure everything is correct. Sometimes it may not be the correct thing that you want. Sometimes it may not be your style of going with it. But the nice thing also about this is that the more code you have in your project, the better the AI becomes, because like it reads through your code and tries to generate code that is in your style and dependent on the code that you already have, basically. So as you can notice right here, usually what would happen is that the typical case would be to handle errors, and to do all that crazy stuff and to not use designated initializers. But since I've already done that in multiple places, it picked up on that, and now it just does that automatically for me. So the more the project becomes, the bigger it becomes, the less that I have to correct the AI most of the time, pretty much. But you still have to direct basically everything. Anyways, so here we got this type as always, the surface, the minimum image count. For this, don't bother too much with this, just say minimum image count +1. But this is basically the minimum images in the swap chain. And basically the swap chain is related to the presentation, to what is it called? If you're coming from GFW or like OpenGL in general, it's called GFW swap buffers maybe, or I don't remember honestly. But either way, swap something. I don't remember, or even SDL, I believe. Yeah. Anyways, whatever. But basically, when you have double buffering, that's what it is, right? So you in OpenGL just activate double buffering, but no, we don't do that here in Vulkan. In Vulkan, you actually create the swap chain yourself, so you have more options here. You have to handle a lot more basically. So here, instead of telling it if it's double buffering or triple buffering or whatever, here actually tell it how much images you want. So like if you want double buffering, you would say 2. If you want triple buffering, you say 3. But just a general rule of thumb, if you don't have a specific thing in mind. And by the way, this is the minimum. This is just the minimum. Like the actual implementation itself, or the driver gets to choose how much images you're gonna have. Here you just get to like tell it the minimum that you want. Yeah, so here the image format. Now if you go back to the Vulkan Caps viewer in the surface, so notice that the surface extension in my case is Win32 surface, and this is the minimum image count in my case, it's 2. So double buffering is the minimum. Right, so max image count is 8, and max image array layers is 1. Okay, so this is not important right now. There's also some other stuff right here. But this is what's interesting right now, the surface formats. So depending on the system and the driver and all sorts of craziness, you're gonna have different formats. So in my case, in Windows, on NVIDIA, with this particular physical device, in this particular version of the driver, I have this surface formats. I have BG, BAGH, RH, AH UNORM with this color space. All of them is this color space, and you would usually just use this color space unless if you're a nerd or you have some weird use case or some weird physical device. Anyways, I'm just gonna use this, and it's already being used here, but it's 0. So it's kind of like the default value, so I don't really have to specify it actually. And here the image format, I'd like to use sRGB. Now, if you want to be fancy, you could go ahead, enumerate the surface formats programmatically instead, just like to get this information right, and see if you can find this And if you don't find it, you could do something about it, like crash or choose a different format, or you could go all wild about this. But I'm just gonna go with sRGB. I don't care, you know. And usually it's supported sRGB. Most monitors nowadays are. In fact, if not all of them are sRGB. So drivers and monitors that doesn't support sRGB doesn't even worth it. Anyways, whatever. So, and by the way, you don't even have to actually enumerate and check if the format is there. If it's not there and you specify it here, Vaki create Swapchain would actually fail. So no need to actually check in the first place if you're just gonna crash or whatever. The same thing with extensions. People would go ahead and enumerate the extensions just to see if it's there or not, and if it's not there, they would crash. I mean, bro, like if it's not there, the create instance function would fail, and you cannot create the instance. So, why bother? Unless, of course, if you need some fancier ways of handling that stuff. Anyways, whatever. Okay, so here we have the current extent, the image extent. Now this is the size of the images in the swap chain, and this is the reason why we have to recreate the swap chain every time the window gets resized, because this is the actual size of the window. Of course, the physical size, the inner size of the window, right? So in my case, I don't really need to even use Win32, because if you get the surface capabilities using this Vulkan function, it's going to give you the window size, the actual correct window size and the current extent. So in my case here, where's the current extent? For some reason it's not included. It was included before, maybe it's got removed. I don't know. Either way, it doesn't really matter. Now image array layers 1 is fine. You may want to use multiple array layers in your swap chain. Let's say if you want VR, not really VR, I mean stereoscopic rendering. There's a lot of use cases you could do. You could go wild, but one of the most used cases for having, let's say for example, 2 image array layers is stereoscopic rendering, at least in the swap chain, though it does have other use cases in other places, like let's say texture arrays, and that's basically that. Whatever, like in Minecraft and stuff. Stereoscopic rendering. Let's see some images. That's not a great images actually. Is it stereoscopic or stereoscopic? I'm not sure, honestly. But basically, you need to render 2 eyes. You need to render for the 2 eyes, right? You need to render one image here and the second image here. But the thing is, they're very similar, right? One image is just like kind of like translated from the other image a bit. So instead of doing the rendering, like more expensive rendering, you could use this to optimize, like you could use 2 layers to optimize this a bit by just, you know, rendering once, and then for the second you shift the image a bit or something like that. Either way, I never really used it myself, but it's something that you could try out. Anyways, so the image sharing mode, this is not, you don't have to care about this if you're using 1Q family. For both presentation and graphics and such. In our case, we're only using 1Q, so we shouldn't care, and it's 0 by default, so we could just remove this. Okay, cool. This is color attachment, so if you're going to be using the Swapchain image to render to it, using a pipeline, Renderpass, etc., then you're going to use this, which we're going to use. So pre-transform, current transform, this is fine. This is only, I mean, it could also be useful for desktops too, but it's usually useful for phones, which like you could change the screen orientation basically. So depending on if you hold it vertically or horizontally, This matters. I don't really know how that exactly works. Either way, for me at least, I always just set it to surface capabilities can't transform. I don't really bother with that. Composite alpha. So do you want to support transparency in your rendering? In my case, I don't care about transparency, so I'm just going with opaque. Otherwise, you have to bother with these stuff, right? Alpha, either pre-multiplied or post-multiplied alpha. Either way. Present mode. Now this is quite interesting. This is interesting. You know VSync? Well, this is related to it. But in like OpenGL, which you just say, either you want VSync or not, in Vulkan actually have more control. You have multiple modes of doing this, of presentation. So let me see. For my case, the ones that I support, like the ones that my combination of hardware and software supports is, what is it? Surface. Yeah, there you go. Present modes. There's FIFO, FIFO Relax, Mailbox, Immediate. Now FIFO is guaranteed to exist on all platforms. Not all platforms, but like on all compatible Vulkan implementations, right? It's in the spec. It's guaranteed. As long as it supports Vulkan, it supports FIFO, right? So the FIFO Relaxed and Mailbox and Immediate, especially Mailbox, like in Linux at least, when I was in Linux, Mailbox, I didn't have this. So yeah. But like basically FIFO and Mailbox are actually VSync on. FIFO Relaxed and Immediate. Immediate is basically no VSync, it's just rendering, that's it. You can get real crazy tearing with this. FIFO Relaxed, it's kind of VSync, maybe VSync. So it's FIFO, but it's not too strict about it. So occasionally you can get some tearing, but you usually don't. Now depending here on the performance, the latency of the frames, etc. that you want. So like VSync would result in no tearing, like strict VSync, which is going to be either FIFO or Mailbox. If you want like maximum performance, but you can get a lot of tearing, Immediate. But yeah, got the point. Anyways, so how this works. Now FIFO would basically, just the typical VSync that it's like it's just gonna, I have a video that I know of is pretty good at this, honestly. They can really, hold on, Swapchain, Vulkan. They can really explain this way better than me. Let's see which one. This one, yeah, this one. Really, really recommend this one. They really explain a lot. You could check it out. You would learn swap chains for sure with this one. In fact, they have a whole series that you could check, like a whole series of videos. It's very helpful. It was very helpful for me. So there you go. But yeah, for Mailbox, it would be VSync, but it kind of like a combination of Immediate and Mailbox. It's gonna keep on rendering like every time, like it's gonna keep on rendering frames, right? But it's gonna throw the frames that couldn't make it with to the VSync, right? And present the ones that could make it into the VSync. In FIFO though, what would happen is that it wouldn't render new frames, well, at least until some certain limit, right? It wouldn't render new frames until the VSync catch on, right? So this is way more energy friendly, like, but you could lose some FPS right there, some frames in the process. Mailbox though, it's maximum performance. You're gonna keep on rendering frames and just throw the ones that couldn't make it and present the ones that could make it. But in practice, yeah, honestly, for desktop, I would go with Mailbox, really, if it's available. Now, this one, ideally, you would like to check it because a lot of times you wouldn't find Mailbox supported. right? But in my case, I'm not gonna bother with it right now. I'm just gonna go with mailbox since I know I have it. But yeah, for this one, it really matters. You really want to check for it, but we can do that later. Otherwise, just set it to FIFO. If you set it to FIFO, you don't have to check. It's always going to be guaranteed to be there. Otherwise, the swap chain creation would fail. So yeah, let's go. Other than that, did I miss anything? Okay, image color space, share mode, key family. There's also key family indices and key family index count. Now this doesn't really, key family indices, it would be important when you have multiple queues for the swap chain and you have image sharing mode on and stuff. But I don't care, like we only have one queue and exclusive. The key family index count, key family index, where is it? Key family, where is it? What? But yeah, it doesn't really matter in our case, I believe. Anyways, so the other one that we have finally is clipped. Now this could be vacate true or vacate false, basically 1 or 0. Now you would usually want this clipped on to be true. This is better for performance than clipped off. But let's say you want to capture, let's say you want to implement screenshot of your application, right? You want to screenshot the window, then you may want this false in some case. Basically, when you have a window covering your window, like here's my IDE right here, it have its own window, right? Now this Explorer right now is actually covering this window. Now the pixels that are behind this window are in defined state, as long as it's clipped equal to true. If it's equal to false, it will always be there. But yeah, this could be better for performance, but you gotta be careful if you want to make screenshots and some other window is covering the window that you're screenshotting and stuff. Either way, whatever. Cannot resolve symbol swap chain. Yeah, let's add a swap chain here. Where is it? Vacate swap chain KHR. Swap chain. Yeah, okay, cool. Let's go with the swap chain here. The other thing that we're gonna need actually is the swap chain format, but currently we're just hard coding it anyway, so it's fine. What else? Is there anything else? Yeah, we're gonna need some other stuff, but I'm gonna show you. Okay, so after creation, but hold on a second. Now we have two cases. Either the swap chain is already created and we have to recreate it, or the swap chain, it's the first frame and we have to actually create it. So let's see how we can do this. So since we're using designated initializers, which means that the swap chain will be null at first. It's not going to be initialized, right? So we could check if the swap chain is already there. So let's see. In both cases, we do want to get the service capabilities. And in both cases, we're going to pass in the old swap chain here. So old swap chain is equal to the current swap chain. And I'm honestly just going to set this to old swap chain here because we're going to override that later on. So I'd better store it first of all. So autoconst old swap chain is equal to app swap chain, because later on I'm going to override that app swap chain. So I'm going to keep the old swap chain reference to it. Now in both cases it's fine, since if there's no swap chain this would be null. It's like I didn't specify this at all, and if it is, well, there you go. So great. Now the next thing, now what's different between the two states, the two cases, is that if there is an old swap chain, if there was an old swap chain, then we have to destroy it. Otherwise, now here where really destroying matters. When the application closes, destroying doesn't matter. It just the OS would clean that stuff up who cares? But this would matter, because otherwise you're gonna get a memory leak in your application. Every time the swap chain gets recreated, you're gonna have a swap chain that is left lingering. So if all swap chain that we want to destroy, so vacate destroy swap chain, khr, app device, old swap chain, allocator null. Great. That's basically it for that one. Now the other thing that we want to do, and this one we also want to do in both cases, which is to get the Vulkan, the swap chain images. So the thing is, the swap chain images gets allocated and created by the WSI layer. So basically the implement, like the loader actually. The loader would actually take care of this using the operating system, blah, blah, blah. It would do the job. But basically we just need reference to those images, but we don't own them. So it's like, it's not a unique PTR, kinda. We just get a pointer, right? So here's how to do it. We need first of all to get the vk get images khr. Let's go. App device, swap chain. Now here what I'm going to show you the pattern of actually taking an array, because here, although we have said minimum image count is equal to this, but this is not necessarily, it could be, but not necessarily the actual image count. This is just the minimum that we have set it here. So we should actually query the count first. Right? So let's query it. Let's actually store it because we're gonna need it. Images count. It's gonna be UN32 image swap chain image count. Right? Great. And now let's actually store it there. So swap chain, where is that thing actually? Oh yeah, my bad. The swap chain in my brain needed to be recreated at that point. Anyway, so making it images khr, and here we're gonna pass in null PTR because we want to query the count. And then after getting the count, actually, yeah, there you go. And then after getting the count, we need to store this somewhere. Now, what you would do here is you would allocate some dynamic memory to hold the images, depending on the count that you get here. But I think honestly, this is probably not needed in this case. We could just go with the static array. It doesn't really matter, honestly. I mean, you would like maximally most of the time have 8 images, and even then that's too much. You would usually just have like either 1 image, which is basically immediate mode, I guess, and 2 double buffering, or 3 triple buffering. That's pretty much what you got. So what I'm gonna do, I'm gonna define, well, we don't have to use define anymore, but what you would usually do is basically max swap chain images, and then you would say 3, because you cannot use a variable, you know, or a constant or whatever in an array length. Otherwise it would be a VLA, which is not amazing. So instead of this, nowadays in C23, we have const expr. Now I didn't actually verify this, to be honest, but I would expect it to work the way that I expect it to. Otherwise, please let me know if you guys know. But it seems to work for me. So const expr max swap chain images. Though const expr in C is not like in C++. It's way less flexible. But yeah, type specifier missing defaults to int. Yeah, my bad. Let's actually set this to size t. I mean, yeah, size t. Max swap chain images. Let's go. Now let's set this to, I mean, I would just go with 4 honestly, but just to be on the safe side, let's go with 8. Why not? And let's go with Swapchain images. So it's going to be a vk image handle. Though again, we don't own it, which means we're not responsible to destroy it. So Swapchain images, array, max Swapchain images. Now the array would contain this much of elements all the time, but we're going to use the Swapchain image count to know the length of the array. The actual length of the array, not just the kind of like the allocation, basically. Either way, so now that we got that, we also going to need the Swapchain image views later on. Yeah, we're going to need it later on. For rendering, though we don't need it just yet. But this is what we're going to pass to the actual rendering step to render to those images, basically. But either way, whatever. So that's basically it. Let's go ahead and do the job. Configure Swapchain. If alt Swapchain we destroy it. So if alt Swapchain we destroy the Swapchain, but also what we also do is we destroy the image views. Now yes, we don't own the images that we got from the Swapchain. Those are owned by the implementation, but we do own the swap image views because we are the ones who are going to create it in a second right now. But just to show you, let's create them first actually, why not? So after getting the images, what we're going to do, well actually we didn't get them yet, we just queried the count. Then we're going to put them into the Swapchain images array. Great. And you just feed the count they queried again to the function. Or otherwise you could select a lesser number. Anyways, so after that, what we need right now is okay, what's wrong with the syntax highlighting right now? What the heck? What? Sorry? Okay, anyways. Right, so for U-N32T, I equals 0, I less than Swapchain image count, plus I, app, Swapchain image views. We don't need those braces. I guess? No, we do. Maybe. Maybe not. Maybe? Anyways, never mind. And actually, this is not the way to go about this. So what we're gonna do is we're gonna get the we're gonna create an image view on the image of that particular index, right? So let's go ahead and do this. Well, first of all, I need to load the function. There you go. Let's just put it here, I guess. And let's go. Vk create image view. There you go. Okay, app device. And now let's see. So we got the image. As you can see, we're passing the Swapchain image that we got out of the implementation here through that index, right? And here Swapchain image views. So the image and the image view match using the index, right? So the view type 2D, I believe this is 0, right? Or isn't it? No, it's 1, so we have to have that. And the format. Now we already hard-coded this to sRGB, so this doesn't matter. Sub-resource range, image color bit. Don't matter, don't care that much about this for now. Not a big deal. And I hate this way of initializing things. Just sucks. Go with the actual Spartan way of initializing things. There you go. That's what I'm talking about. What's up, bro? Come on. And the base array layer, base MIP level, we don't care. Those will be 0. Okay, great. So right now just set these like that. These are the default values. Anyways, whatever. So now what's up? Well, now we have created them, and since we created them, we actually own them. So we have to destroy them. So before I destroy the swap chain, I don't think it even matters the order, but just to make sure that's the case, because, well, what you create first, you gotta destroy first. Actually, you gotta destroy last, yeah. So let's go. It's a stack, right? Isn't it? Is it a stack? Yeah, pretty much a stack. So the last thing that you have created, you destroy first. So anyways, whatever. Destroy image view, let's go. That's what I'm talking about. And notice, by the way, that we're using git device proc ADDR here, because the Swapchain stuff is a Swapchain extension, you know, it's an actual device extension, right? So, and this is device specific, basically. So you remember the surface is instance specific, but the device, or the Swapchain, sorry, is device specific. But anyways, so for Swapchain image count, okay, great, let's go. So we destroy those image views, if the old Swapchain, and app Swapchain image count. Interesting. Though just be careful to make sure that this is first before this, otherwise you're gonna have a problem because, well, you got a point. Anyways, so we don't need those, by the way. Useless, since we have one statement there. There you go. And what else? Okay, here too, useless. Okay, let's go. Very cool. So now what's next? Alright. So we got the images and we created the image views. I think that's basically it. Maybe. Yeah, pretty much, I believe. Let's see if I missed something. So yeah, so we got the Swapchain image count, Swapchain images, Swapchain image views. Great. Now what's next? Let's make sure that this actually runs properly without any error whatsoever. Yeah, seems too good. Seems good so far. Do we actually call this function? Hold on a second. I think we're not doing. Yeah, we're not. So let's actually do that. So let's see. I'm actually gonna call that on the resize event. So we're gonna go to our procedure. Oh, actually before that, now the thing is, in our procedure here, we're gonna look for case WM paint. Well, not paint, before that actually. Case WM resize, I believe, or is it something else? Hold on, let's use the AI. Yeah, case WM size. Let's go. So we're gonna, this basically, we get this message when the window gets resized. Oh yeah, pretty much. So what we should do now is we need to reconfigure this Swapchain. But we don't have this on. So I'm gonna take this window procedure down there. Otherwise you could use for declarations, but I hate those because whenever you want to change the signature of some function, you have to change it twice, which sucks. Either way, unless of course if I really need it, like a cyclic dependency or whatever. Anyways, so case WM size, and let's just so we gotta configure the Swapchain, right? But the thing is, we gotta give it the app. Now, what would most people do is they would create global variable, but myself doesn't allow me to do that because I'm too pedantic. So I'm not gonna use that. I'm not gonna use global variables. I hate those. So what I'm gonna do, actually, there's a way to do this in Win32. Like most libraries, when they have a callback like this, they give you some way to provide some user data variable, or some way to basically pass to that callback some extra data, some extra pointer at the very least. So that's what we have here. So when we go to the window, actually when we create the window, hold on, window procedure, what's up? Oh yeah, with this also have to go down. Okay, cool. The function declarations are all over the place. I'd like to order them in some consistent way, either way, whatever. So parameter can be made const. Sure, bro. Let's go. Let's go. The const gang. lparam. Switch message. So case wm destroy. Okay, so this is quite interesting. Oh crap, what the heck? Yeah, this should be here, I guess. Yep, pretty much. This should be here, and let's go. Nice, great. So, okay, so how we can do this? Well, remember this LP param that we have here? We're setting it to null PTR, right? Okay, cool. So what we're gonna do, we're gonna set this to the application pointer. And there you got it. Alright, so now the window would hold our application pointer. Now the issue is how we could get that. Well, we're gonna get it in lparam, but we're gonna get it in lparam only on, for whatever reason, only on one message, which is wm destroy. Sorry, wm create. Right? The AI didn't catch what I'm doing, but it's fine. So what we're gonna do basically, well, first of all, wm create. So get pointer to abstract. Let's see if the AI can do it, or I have to check out the documentation. Hopefully he would. Let's see. What's up with the, something is weird here. Case wm create. What? Oh, well, I need this. Okay, all right, there you go. Cool, let's go. So the AI have cached on. Let's go. So autoconst app, right? And you take this lparam int long basically, and you cast it to a pointer. I know it's crazy, but you cast it to a pointer to a create struct w struct. Okay, so this you get some things about the created window. Basically the things that you have passed to the, when you created the window, a lot of it you get it here. So you get the x, the y, the, what the heck is this? CY? What the like the naming of windows is just wild. But either way, you get like the H instance, the H menu, LP create params. But what we're interested into is the LP create params, which is LP void. It's basically a void pointer, right? So we actually go ahead, we cast it, and then we grab the LP create params field. And then since that's a void pointer, we have to cast it once again to the app, to our app, because Windows doesn't really know what this pointer points to, but we know it since we have passed it ourselves here, you know. So then we get our beautiful application reference, and then we could use it to do all kind of stuff with the app without any global state, No thread local stuff, nothing like that. It's this easy. So there you go. There's other ways to actually do this, but this is the way that I find works for me. Okay, great. Now I'd like to organize this just a bit by actually creating another function called let's say L results handle message, right? And here what we're gonna do, so you're gonna get the app. Okay, I already got what I was gonna do. Cool. So the app, the window, the message. Interestingly, even instead of using lparam, it basically like expanded the macro based AI. Let's just go with it anyway. Actually, no, hold on, what the heck? What? Oh, it was uint. Okay, it's fine. Actually, never mind. I thought expanded wparam or something. But whatever, anyways. So we gotta switch the message, case wm destroy, and then we post the quit message. Basically the same thing, but instead of handling this here, the case wm destroy thing, let's grab this in. Let's remove it from here, and we're gonna do this stuff here. So let's grab this guy. I mean, let me first of all paste, well, never mind, it's fine. Let's do this here. So I'm gonna take the application, right? Now, if we got the app, we're gonna return handle message, app window message, wparam, lparam, right? Great. Otherwise, we're gonna return div window proc w, so just the default callback stuff. So, because we're not interested in that particular message, so we forward it to a default callback from Windows. Cool. So other than that, so if app, now the other thing that we gotta check is if message is equal to wm create, then we're gonna set the window long ptr w of the window, right? gwlp user data. I mean, there is multiple of this. There is either wnd proc. You could basically change the window procedure of the window to something else. Ooh, actually, we could even use this instead. Either way, or you could go with gwlp instance, or change like the instance, or change the parent window, change the user data, which is what we're doing here, to passing our custom point, like our user data pointer, right? And the ID here, I don't know what the ID is. Anyways, we could also do this actually. I wonder if it really worth it, to be honest. I don't think honestly worth it. Like, yeah. I mean, what you could do basically is you could like create another window procedure, right? And that window procedure would basically would assume that the app is there and stuff. Honestly, there's no need. I think this is more than enough. gwlp user data is fine. We set that, and there you go. Great. Actually, hold on. What the heck? No. I'm doing this wrong. Yeah, I'm doing it here wrong. This is right. So here we actually got to use get window long ptrw. Let's go. And that's basically it, I guess. Yeah. I wonder if it's UB to actually custom, not BER. I guess no. Last time I checked, maybe. Anyways, so if app return handle message, app window message, blah blah, and there you go. Cool, great. Now after this craziness, what we could do now, we can handle our beautiful WM size. Now here we're gonna say configure Swapchain app to simply. That's basically it. And instead of break, I guess we could just return actually 0 return 0, I guess. Yeah, maybe. Yeah, there you go. Okay, cool. So that's basically it, I guess. But we're gonna have a problem here. We're gonna have a segfault, I believe. No? What? Interesting. I did expect a segfault though. Okay. Okay. Probably something is weird here. Interesting. Because I was expecting a segfault, and I know why. Let's see. Let's go into the configure Swapchain function. Maybe it's not getting called. Possibly. Actually, it is getting called. Interesting. And the device is even there. What? I was expecting the device to not be there. What? Apparently it's not. I'm not sure what was different from last time I tried this. Yeah, last time I had a segfault because the device was not on, and I had to check to make sure that the WM size doesn't happen until we initialize the device. And for some reason we're not getting that. But just to be safe, honestly, just to be safe, I don't know, maybe Win32 is crazy. What I'm gonna do, first of all, instead of just having a configure Swapchain, because we're gonna have a lot of other stuff later on, like we're gonna have Framebuffers, stuff that depends on the Swapchain. Basically, we can have some other resources that depends on the Swapchain, right? So I'm gonna create another function, right? So here, as you can notice, I'm just using functions to just like organize things, honestly. Not really using them for anything fancy. Otherwise, I'll go that rabbit hole of abstraction, and and the application would become a huge, complex mess. That's why I'm sticking to my rules to make sure I don't go wild. Alright, so and this honestly works. I mean, it's not that bad, at least for now. So now the current rule that I have in mind is that if something isn't gonna be like reused, then there is no need to abstract it. That's basically how it is. Either way, right now, what's up? Yeah, I want a function called Swapchain, setup Swapchain dependent stuff. So anything that depends on the size of the, like the Swapchain, there you go. So setup Swapchain dependent. There you go, based AI. Setup Swapchain dependent resources, configure Swapchain. And we're gonna have some other functions here later on, but for now, this is good. Just a bit of future proofing. Okay, cool. So where is it? Yeah, I started to get lost in my code base already. Okay, let's go. Window procedure. Okay, there you go. Okay, cool. So here, I'm just gonna make sure that the device is on. Last time I did this, I had to check it because it was somehow getting the message before the device got initialized. So just to make sure, it seemed that didn't happen this time, but just to be safe, I'm gonna do that. So if app device setup Swapchain dependent resources app, and we don't need to pass, like, you would get the size of the window in the W param and L param. In fact, you would get it in the I believe it's the low bytes, I guess. Like the low bytes or high bytes or some weird stuff like that. But we don't really need that, fortunately. And in fact, even if we do get that, it would be wrong, because that would be the logical, like maybe the logical size, and it would be the logical size of the outer window, not the inner window. Either way, it's gonna be wrong, right? But thankfully we have that get Swapchain capability, service capabilities, which already does the work for us to get the extent. There you go. So that's great. Okay, so right now hopefully we shouldn't get any crash once we resize the window. And hopefully we don't have any memory leak. I mean, it doesn't crash. No clue. No clue. But it would crash if I do something interesting, which is, hold up. What? Are you kidding me? What the heck? Did I upgrade my system or something? Or the driver? What? What happened? I was really expecting it to crash. Maybe I'm using the wrong message, honestly. Let's see. Okay, hold on. Let me see. Set up dependent stuff. Yeah, I'm probably doing something or something fishy going on. Because I was expecting 2 crashes and I didn't get any of them. There's 2 states of a programmer. Either you get an error, like, no, nothing works and you don't know why it doesn't work, or it works but you don't know why it works. Either way, it's bad. It's not good news. Let's see what's up. Okay, let's just ignore this. I don't care about this one right now. Okay, can you go on with your business? Okay, great. Now if we resize this, okay, we do get called again. Interesting. I mean, yeah, this is fine, but like, why doesn't crash when it becomes 0? Let me make sure that's the case. Hold on. Wiki creates. Oh, by the way, do I have that to be break? Hold on. I guess maybe I don't have the Vulkan configured. Yeah, I knew something was wrong. Let's check the yeah, this would definitely break now. Okay, make sure you have the validation on and break on, because we're not handling the errors in the application itself. Okay. Huh? It broke already? Or what? Oh, it's just the breakpoint. Hold on. Let's remove that. Alright. Now let's resize this. Everything good so far, but if we do this, there you go. I told you it would crash. Let's go. And it crashed because there's an error of validation. Not really a hard error, it's just a validation error. So vacate create swapchain KHR. So image extends width 763 and height 0 is invalid. The Vulkan spec states image extent members width and height must be both non-zero. Okay, and you get a link. If you take that link, you're gonna go directly to the spec. Unfortunately though, it takes you to the old spec documentation, which takes forever to load. It's so clunky, but this is the new spec. I wonder if I can find it myself though. Okay, let me go to the new spec. So you can go specs, Vulkan 1.3, and this is the new spec. Much nicer to look at, loads faster, much better. Let me see if I can find it here. Search the docs. Where it broke, by the way? Vacate create swapchain, I believe. So we could search that up. Search this up. Okay. Oh, what? Broken search or what? Interesting. Okay. What? What? Where is VK create Swapchain KHR, bro? There you go. Okay, we'll click the link, and there you go. Now this is the spec. This contains all the information you'll ever need about how Vulkan works, because this is the spec. Both the implementation, like who will implement the Vulkan driver, and the one who uses that API, which is us as the, so basically both the application developer and the driver developer both should ideally read this. And this is basically like the agreement or the contract. That's what basically an API is in the spec, between us as the application developer, what we expect when we call some function and what arguments, etc. And also the same with the driver developer who develops the driver, the Vulkan driver for their own GPUs. So yeah, but if we basically go to I think Swapchain, create info KHR maybe, let's see, image extent, let's go to the image extent. There you go. Okay. Is the size in pixels of the Swapchain image, the behavior is platform dependent. Notes on some platforms. Though it's minimized. Why it doesn't mention that? I mean, it's mentioning the 0, but it's mentioning something. But it's saying that it's fine? What? Weird. Or maybe I'm not understanding it. Huh. No clue. The valid usage. Does this error have a... Oh yeah, there you go. Okay, it does have a VUID. Maybe I could use that VUID to find it. Okay, there you go. Look at that. So valid usage. And as you can see, it's right here. Image extent members, width and height must be both non-zero. So you can find all the valid users. So surface must be a surface that is supported by the device that's determined using VK get physical device surface support. I didn't actually check for this, but it's usually the case. So I didn't really bother. In either way, I'm actually skipping over a lot of details. Not a lot of details, but like a lot of things that you don't really need to know right now and that tutorials would actually cover. I mean, like the minimal Vulkan stuff is enough for a beginner. It's more than enough. Yeah, right now we have a broken thing. Oh yeah, I can stop it like this. And let's go. Great. Amazing. So how we could fix this? Well, we gotta make sure when in the setup Swapchain resources, right? We could check if, well, actually I don't have, interesting. I don't have the size here. I mean, I could get it from the Win32, but I don't want to because it's clunky as heck. So I'm gonna do a little hack. I'm not sure if I can call that hack, but I'm gonna return Boolean from here. What's up? And then after I get the surface capabilities, if surface capabilities current extent, what the heck? Yeah, it's using get client rex. By the way, get client rex is the one that you would use if you want to actually set the size correctly of the window, like for the inner window and stuff. You would get the client rex, but we don't really need this here. The AIs have drunk something. Anyways, if surface capabilities current extent dot width is equal to 0, I'm not sure what it's trying to do there, but either way. So if this is 0 or the height is equal to 0, If you guys have any questions, by the way, let me know. And so if that's the case, we're gonna return false. Right, no return statement, returning on void. Okay, sure. Let's actually return true at the end. Meaning that everything is good, I guess. So if that's the case, we're gonna return false, otherwise we're gonna return true. Great. So here I'm gonna say if, the problem, well, that does mean that anything that we can use this with is that should be after the Swapchain, which I believe probably would be. Either way, whatever. Right now, though, we don't really need this stuff. Could just configure the Swapchain app. But later on, when we're gonna create the frame buffers and stuff, we're gonna need that behavior. For now, it's fine. Maybe we could actually do this, meaning that something is being returned, but we're just not handling it yet. Okay, great. So that's basically it for now, for the Swapchain, I guess. So hopefully I didn't mess up something here. I'm just a human. Okay, great. So what's next? Well, next I think we could go with command pool and command buffers. Let's see. Or actually we could go, yeah, it's fine. Let's go with command pool first. Why not? You could go with some other way, but anyways, let's start with command pool and then the command buffers. Now the command buffers, we're gonna have context per, well, actually, I don't want to handle in-flight frames just yet because it would confuse us even more. I think let's actually start with the shaders first, okay? Before the command pool, command buffer stuff. Let's start with the shaders. Okay. So let's go to the tutorial. Right now I'm going to use it as a reference. Where is it? Where is it? So let's go to the Vulkan tutorial. Okay, drawing a triangle. Let me show you just a glimpse of what could be, of how much I have skipped. Let me see. Create the first Vulkan object. No engine. Okay, you have just set these names and versions. You don't have to, it's optional. What else? There you go, they're actually doing the layers there. Though, to be fair, you have to enable these layers if, let's say, you want to debug in somewhere where you don't have access to, the Vulkan configurator, then yeah. Like, let's say, Android or something, but that doesn't even, that doesn't affect us. We're only implementing it for Windows. We don't care about cross-platform stuff now. Vacate create instance. There you go. And he's also, I believe, checking if the extension is on there. No? No. In macOS, by the way, you're gonna get this error, maybe. Yeah, vacate error incompatible driver, possibly. And yeah, just check out this. You have to do some extra steps for macOS because macOS doesn't support Vulkan officially, though there is an implementation out there called Molten VK, which I believe you can install, right? And it would give you it's basically like a wrapper. Not a wrapper, but like, yeah, it's an implementation, but not fully confirmed though. Not fully confirmed to the spec, at least not yet. and it basically maps Vulkan calls to Metal calls, like to Metal API, because Mac OS apparently have their own graphics API, Metal, called Metal. And yeah, they refuse to use Vulkan, and they actually have what is it called? Deprecated OpenGL, right? You can only use OpenGL 3.3 currently, and in the future they may even remove it. Well, it's deprecated. That's exactly the definition of it. In anyways, so checking for extension support. There you go. They're checking for extensions and stuff, and all that crazy stuff. Honestly, I feel like this shouldn't really be given to a beginner, but either way, we may do this though later on. But for now, at least, I want to bother with that. Validation layers, you gotta check for the queues, blah blah blah, whatever. Either way, let's go right now to the. So we're kind of done with the presentation, right? Yeah, we have done that. Now the graphics pipeline basics. Now this is where the actual graphics. Finally, we have reached the actual graphics. So this is the graphics pipeline. So you get your vertex and index buffers, though we're not going to use buffers yet. We're going to hard code some geometry data in the shaders themselves as a first start, because apparently creating buffers in Vulkan is not that simple. It's not that hard either, but it does take some work. Okay, so we gotta start somewhere. Yeah, there you go. We have vertex index buffers, so basically the data, the geometry data. It goes into the input assembler, right? And then the vertex shader, which basically transforms these vertices around. You know, this is where you use your projection matrix and all sorts of stuff to fake 3D and cool stuff like that. Like, let's say you have some leaves and you want them to wave around. You would transform the geometry, the vertices, using some sine wave and stuff, depending on the, let's say, the Y position of the vertex in the 3D space, blah blah, whatever. It basically you transform geometry around the tessellation. The tessellation, it's an optional step where you could basically make more triangles out of the geometry, generate more triangles inside of the geometry. Like, for example, it could be used for terrain. Let's say you're making a space game, like Kerbal Space Program. I love that game. So you have a huge terrain, and if you were to render that whole terrain, like all of it with all of its details, bruh, you're gonna block your whole computer. There's no way you could do that. Unless if you have NASA's computer, then maybe. Yeah, so you could use tessellation. So when the camera is closer to some patch of terrain, you could actually generate more geometry in that place where there is, like, the player is closer, and otherwise generate less geometry when the player is further. So yeah, it's basically advanced LOD, I guess. Dynamic LOD. Can I even call that? I don't know if it's legal to do that. Anyways, geometry shader. So the geometry shader, you could use it to generate new vertices. This is also optional, just like the tessellation stage. But I wouldn't recommend to use geometry shaders at all. Nada. No. Just don't do it. This is super bad. It's really bad in terms of performance. Tessellation is fine. Yeah. Geometry, no. But there you go. You could actually use it to generate new vertices in the shader itself. But it's super bad. Like, for example, I believe some Intel implementation actually does this in the software, in the driver itself, instead of the GPU or something. I don't remember honestly, but either way, it's a bad idea to use geometry shaders. The new shaders that would replace this is the mesh shaders. So you could use that to use compute shaders to actually generate new geometry and stuff, whatever. There's a rasterization, where we take this geometry, right? That's just mathematical representation of the geometry, right? And make it discrete into pixels. So we rasterize it, right? So if the actual pixel, so like in the monitor, right? If it's inside that geometry, in that triangles, then we color it. We use the fragment shader to give it a color. Well, in this case, in this stage, it's either inside or outside, black or white, you know. Black in this case is inside and white is outside. So, and depending on the resolution, you know, of the monitor, how much pixels in it, you're gonna have more or less quality, basically. Anyways, so fragment shader here, where you actually take that rasterized fragments and then basically give them to a fragment shader, and then you're gonna get some like the vertices, the geometry data, right? Like the UV, for example, of textures, and if you have that, and the color maybe of the interpolated color, and you basically use those data, right? Like the position stuff, to calculate some color, basically. And that's how you actually implement everything, like lighting and stuff. And then finally color blending, because you could have multiple triangles on the same pixel, right? That covers the same pixel. But depending on your color blending settings, right? You would either blend those things if you support transparency, or otherwise the triangle that is closest would just cover on the triangle that is farthest. And you could go wild with this. There is some, although this is like fixed state, these color blending, rasterization, and assembler, they're fixed state. So you just have a couple of knobs that you can tweak to change the behavior of it. So like just some options. But there is these programmable stuff, those programmable stages that you could actually write code in, shaders basically, and you have more control there, right? So like the old OpenGL, like the OpenGL compatibility, these stages were actually all fixed, so it wasn't programmable. So like you would have the lighting done by the driver itself and the GPU, and yeah, and you just had to, but like you had limited options. But right now, since you have shaders, you could go wild, basically. We also have compute, and in the color blending, by the way, if you want to know which triangle is closest, well, you can't just magically know that. You're gonna need a depth buffer to help you with that and stuff. But either way, the input assembler collects the raw vertex data from the buffers. Yeah, you guys can read this to get even more details. I'll just give you my little description on it, at least from what I understand. So yeah, there you go. At least this is the explanation, I would hope, if I was just starting. So drawing, frame buffers. So Swapchain, frame buffers. Okay, well, we're gonna need frame buffers, but after we create the Renderpass, oh yeah, I skipped over a whole stage. Okay, so now we're gonna need the shader modules. So we're gonna need the vertex shader and the fragment shader. Cool. So this is the frame buffer coordinates, right? It's basically the actual physical size of the window, right? So here you got 0, 0 in the top left corner of the window. You got 1920. Basically, we have full HD monitor here, right? 1920, 1080. There you go. Cool. And the thing is, when it comes to rendering, you actually work with normalized device coordinates. So basically 0, 0 is in the center, and -1 in the top left corner, and 1, 1 in the right bottom corner. Yeah, and here is your vertices, the first vertex, the second vertex, the first vertex, the second vertex, and the third vertex. It starts from 0. So the order actually matters, depending on the order and depending on which, like if you're doing occlusion and which front face you have chosen, it would show up or not show up. So like we're gonna see about that in later on when we create the pipeline. Either way, right now we could go into actually creating the shader. So let's actually copy this. So as you can see, we're just hard coding the shader, some shader data, like I mean the triangle positions into the shader right now. Later on though, we're gonna use buffers to actually get that, because you can't really do much. Can't do much with just hard-coded geometry. But anyways, let's actually take that on and let's create some folder here or whatever. Let's actually create an src folder. Put the main.c there, refactor. Let me make sure it refactored correctly. No, it didn't. Interesting. Let's do src/main.c there. And let's make a res folder for resources. And I guess let's make shaders directory, and we could create a new shader. Let's call this, I don't know, triangle.vert. And let's paste this in. You could look for some GLSL plugin to add some syntax highlighting, but there you go. Other than that, we're good to go. So we have here basically an array. So this is version 450. I believe the latest version is 460 though. And the positions array have 3 vertices. In this case, it's like 3 vec2s. There you go. 0.0, which is, I believe, the center. Is it? Oh, I mean, at least in the x-axis, right? And minus 0.5 in the y-axis and stuff. Either way, whatever. And here we have the main function, gl position equal vec4 positions gl vertex index 0.0, 1.0. Now, now this function right here gets called for every single vertex in your geometry. So it would run, in this case, if we have a triangle, it would run 3 times. It would run once for this one, then this one. In fact, not then. They would actually run in parallel, or at least probably they would run in parallel. So they would run at the same time, I guess. Yeah. Using the GPU, of course. So gl position equal vec4. Now this is a global variable, right? You set the position of the vertex. In our case, what we're doing, we're setting it, so it's a vec4, so basically have 4 components. It have x, y, z, and w. X, y, z, as you know, is just x, y, z, like the actual 3D coordinates. The w, though, is for some interesting matrix stuff that we're gonna look into later on. But you usually set that to 1 for now, at least. Okay, and then 0 for the z-axis. We're not dealing with 3D, at least not yet. And here for the x and y, we're just passing it the position from the array. The index, though, is the GL vertex index. This would basically be the index of the vertex. So if the shader is currently running on this vertex, it would be 0. The GL vertex index global variable would be 0. Otherwise, here it would be 1 and 2 here and stuff like that. Yeah, I think this is very clear. And yeah, that's too simple actually. And now let's go to the fragment shader. So triangle.frag, and let's copy the shader. There you go. Version 460 in my case. Layout location 0, out color main, color equal vic4 1.0. So here again we have this main function, and this one would run for every fragment. If we have only one triangle and no triangle that is overlapping with it, then you can say that that fragment is a pixel, basically. But like the technical word is fragment, because you could have multiple fragments in one pixel overlapping, and then the job of color blending stage is actually determining which fragment contributes how much and how, etc., how they would blend together, basically, those fragments in that pixel. Should we like mix both together? That's basically transparency, or should we just discard one because one is opaque and whatever. Anyways, so that's essentially for that one. Now we have this out color. It's an out variable here. It's a vec4, and location equals 0. Now basically later on we're going to create a frame buffer, and we're going to pass that frame buffer to be rendered into a render pass, right? So what's going to happen is that we're going to put that frame buffer in location 0, right? And that's basically what we're going to basically write into in this case. We're going to draw into the frame buffer, which is going to come from the Swapchain image, basically. So here it's RGBA, that's why it's vec4. It's 4 values. A is basically alpha, and red, green, and blue from 0 to 1. So 1 would be full intensity of color of light of that particular color channel, and 0 would be none. So if you have no light, you have black. If you have lights on all of them, then you get white. If you got only a red light, well, you got it. Anyways, it could mismatch together. Like if you want yellow, you would take a red light and the yellow light, mix them up together, and there you go, you got yellow. Anyways, so that's basically. And by the way, this color model is called additive. This is how light works. The other color model I think is called subtractive, maybe, I don't know. But like, let's say you have red pencil, or what do you call it? I don't remember what you call it. Yeah, let's say pencil, right? So you have a red pencil and a green pencil. If you mix them up together, you wouldn't get actually yellow. You would get a darker color, because like instead of adding colors together, you subtract when it comes to paper. In light you add. Anyway, so like when you mix red, green, and blue in paper, I believe you maybe get black. But on the other side, when it comes to light, you actually get white. But yeah, it's basically reversed. Anyways, whatever. Triangle vert and triangle frag. Now there's what we gotta do. Now the thing is about Vulkan is that it uses per v bytecode. So the thing is about OpenGL, what you do is that you pass the whole source code, GLSL code, into the API, into the driver, right? But that's apparently didn't go super well. So like, because every vendor, like every driver would actually implement their own compiler of GLSL, and they would be vastly different in some cases. Like something that would compile on one driver wouldn't compile on the other, and vice versa. Because like, you know, when it comes to actual source code, there is a lot of things that could go different in terms of implementing. Like one compiler would be more strict when it comes to the specification, and the other would be more relaxed, and so on. So that didn't go so well. and the compiler wasn't like the best most of the time. So what happened, how did Vulkan solve is by actually making you compile this source code into an intermediate bytecode, kind of like LLVMIR. You actually compile it offline using a SPIR-V, like you compile it into SPIR-V bytecode, and then you feed that SPIR-V bytecode into, which is way simpler than actual source code. It's not exactly the actual code that would get run into the GPU, but it's, you know, it's very simple. It's just bytecode. So yeah, now let's actually compile it up. So if you download the SDK, you should have a shader C compiler. It's called GLSLC. Let me see. Yeah, there you go. There are no input files. So I should say GLSLC, and I can give it my shader. So you just run the terminal on the directory of your project. And I'm going to say GLSLC res/shaders in my case /triangle.vert. Oops. Okay. And yeah, there you go, -a.spv. But honestly, let me tell it to put it somewhere. Hold on. Well, the thing is about this is that it's kind of like development resources, not really the actual res that we're going to ship with the engine or the application or whatever. So honestly, what I would do, I would have two kind of folders, maybe. So I could easily, you know, yeah, let me see. So how can I actually, rename? Okay. So instead of res, I'm going to call this maybe development res. Let's call it development resources, I guess. And let's create another folder. Let's call this resources. Let's create a shaders directory just to keep things organized. And now we're going to actually compile this, and we're going to say -o. And by the way, this is going to be now development resources -o resources /shaders /triangle.spv .vert.spv. SPV is the extension for the SPIR-V bytecode. Okay, great. So that's the one for that. And now we got our beautiful SPV. Great. Next up, we can do, oopsies, what's up? Okay, so we're gonna go with frag now for the fragment. Just gonna, instead of vert, say frag in both cases. And there you go. So now we got our bytecode. Great. We don't need the source code anymore. At least the application doesn't need it, but we do need it for development ourselves, because we would like to maybe, you know, change the shader and then compile it again. Anyways, so now let's just go into src, and we need to load a file. Apparently it's not the, I don't know actually how to load a file using Win32, by the way. Interesting, we'll see. I mean, I can do it using the standard library, but it would be interesting to do it using only Win32 though. That would be cool. Never done it before. Let's see. Okay, let's see if the AI can help us here. Load file using Win32. Void. I mean, would it really be void? IDK. Anyways, let's say load file, right? And here what we got. So we basically done create file A, file name, generic read, file share read. What is this sorcery? Open existing file attribute normal PTR. What is this? Okay, so the first one is the file name. Okay, the second was the desired access. Oh, okay. Share mode is the third. Share mode, interesting. Security attributes is fourth. And DW creation disposition, what the heck? Flags and attributes and a template file. What? Anyways, so you see if this is invalid handle value. So if that's the case, then well, we have failed to get a file. Now we got data equal null PTR and size equals 0 return. Otherwise, if it didn't fail, then we say size equal to get file size file, and then we allocate memory using the process heap 0 size, then dword read file data size read no PTR, and then we close the handle. Okay, interesting. I feel like doing something similar to Vulkan, how they handle that stuff. But hold on, no, that wouldn't work actually, because we still need to open file handle, and here it seems like even to get a file size you need to create a handle, interestingly. Anyways, so create file W, and this would be a wchar_t. This is 2024, so we should use Unicode. File name, generic read, file share read, if file equal invalid handle value. I think I'm gonna return boolean and say like if it's failed or not, or yeah, I think we could return a boolean, and if it failed we could return false, I guess, and then otherwise we could return true maybe, and there you go. Cool. And here we actually allocate memory using heap alloc. We could use virtual alloc possibly, but it's fine. This seems to be fine. I believe there is a, oh yeah, I mean this is the default process heap. Okay. Anyways, so this should be fine. It should be fine. It would give us the data and the size. Great. Amazing. What's up? Add const. Cool. And let's go. So now we got a load file function. Now let's actually load some shader modules. So we're gonna have a shader module, vertex shader, and fragment shader. And let's create them. So we can create, after the device, we can create the shader modules. So create, honestly, I'm just gonna put it in a function called, well, hold on. I mean, honestly, we're not gonna need shaders for the whole lifetime of the application, so there's no real need actually to put it here. Here's what I'm gonna do. I'm gonna create a shader create pipeline function app, because we can actually destroy the shader modules after we create the pipeline basically. So create the device, then create the pipeline, and now we're gonna say void create pipeline. Okay, and let's grab the application pointer. Where is that? Okay, so create pipeline, const app. So yeah, let's go ahead and say, well, first of all, we need to load some functions, of course, as always. Autoconst vacate create shader module. Let's go. And destroy shader module. We're gonna need that too in this function. And now let's just say vertex shader. But vertex shader module, please. What the heck is that? No clue. That seems like a lambda. Does C23 have a lambda? What the heck? No way. I don't think that's the case. No way. What? I don't know. Anyways, I'm gonna say vertex shader bytes, honestly. And let's just say Lloyd file. And here we give it the file name, which is in our case would be, well, of course, Unicode file name. And it's gonna be resources /shaders /vert.spv. Yeah, let's go. Now instead of autoconst, we're gonna go with, well, it's gonna be maybe Win32t. Is it pointer? I don't think it should be const. Yeah. Okay. Let's see what we got here. Is implicitly converted to compatible. Huh. What? Type void. Ooh, okay. Let's actually convert explicitly, I guess. Or we could just say void anyways. Yeah. Let's go with void. And then size t vertex shader size. And of course we're gonna pass here the vertex shader size. Or otherwise what we could also do, instead of returning a boolean, we could go with size t here. I mean, it could be that it's yeah, it could be that it's a file that have a 0 size. I don't know about that. Maybe. So let's not do that, I guess. So now, if we couldn't load the file, which is to be expected, that's why I handled the error. What should we do in this case? I think we're just gonna crash, at least for now. Yeah, let us crash for now. So if not load file, then what should we do? Yeah, let's use message box again. The base message box. Cannot find vertex shader. Let's go. And what else? Now let's do the same with the fragment shader. Well, instead of vert spv, oh, it should be triangle, the vert in our case. In triangle.frag.spv. Now I'm gonna make sure that what my working directory is correct. It's not set to anything apparently, I guess, so gotta set it properly. So where it is, maybe C-line projects. I called it codoxal, okay. And yeah, let's do it in the root directory of the project, fine. Let's apply And that's now the working directory. Great. Make sure to do this. Okay. Now this should be good to go, I guess. Let's make sure at least this even works. Can be made pointer to const. Let's try this out. What? Oh yeah, we haven't used that yet. Oh crap. Okay. Void. Void. I just want to see if this even works without errors. Set up Swapchain. Oh crap. I thought I was using Rust. Apparently you cannot do this. Okay, so let's just ignore it. Okay, cool. I mean, it doesn't give a message box, so I would guess you have done it properly. So there you go. Now we got the bytes. We got the binary. So now let's create the actual shader modules. Let's go. Create shader module. Well, of course, first of all, we need to create, I mean, it should work like this though. App. Oh, I mean, yeah, that's true. Okay, never mind. Let's actually declare those. Vertex shader module and fragment shader module. And yeah, there you go. So create shader module, device, create info code size, p code. And is there anything else? Doesn't seem like. So that's basically it. And now we again create another shader for the fragments. And there you go. Now after we're done with our pipeline, we're basically gonna destroy the shaders. But honestly, I'm gonna put this whole thing, I guess, into its own function. I mean. Now, if we want to do that, we actually have to put it in the application, though. Yeah, it's fine. Let's do that. Why not? For now, at least. Okay. So void create shaders or Lloyd shaders. I think Lloyd shaders makes more sense. And let's just paste this in. And now we're gonna need the shader modules. There you go. Cool. And yeah, we're just gonna make variables for them anyways. So now let's say vacate shader module, vertex shader module, fragment shader module, and let's go down to the function. Now instead of having these, we're just going to put them directly into the application. Vertex shader module, and here app fragment shader module. Stream is still going fine, seems like. Okay, cool. So after creating the shader modules, so create pipeline. We do not need this anymore. Do not need this. And yeah, so we're gonna basically say Lloyd shaders, right? App. And after that, of course, we're gonna enload the shaders after creating the pipeline, though. I mean, interesting. Yeah, actually, we're gonna do this load shaders here before the pipeline, right? and then alloy the shaders after the pipeline. Yeah, after create pipeline, we're gonna do this. So we don't forget. Load shaders, create pipeline. And there you go. So create pipeline. Now let's create a load shaders function. And that's basically it. So once you create the pipelines that depend on those shader modules, you can just go ahead and destroy the shader modules. So there you go. Kind of like OpenGL actually. In this matter at least. Enable to execute at const. Okay, const. Great. So that's basically inline shaders. You don't need to keep it in memory. Oh, I forgot one thing. Yeah, we have allocated some memory, bro. Crazy. Okay, so heap alloc. I think it's heap free. Probably. So let's go ahead and make sure to deallocate the data. It's not a big deal, but still. Alloy the shaders, destroy shader module. Okay. So should we destroy the shader? Yeah, let's destroy the shader modules first. And then heap free. Heap, let's get the process heap. Oops. Oopsies. Process heap. Then what's next? Vertex shader. Heap free, get process heap, mem, application, vertex shader, module. Yeah, pretty much. Let's honestly call this process heap. I wonder if we can cache it. We probably can. It's not like it matters, but I need to check out the documentation to make sure. Can then be used in subsequent calls. Okay. Yeah, honestly, let's grab the heap here somewhere. So let's just say, what is it even called? What it does return? Handle. Okay. Process heap and process heap equal get process heap. Now I could just use that. No need to every time call the function. App? Yeah. Heap. Well, where's the app? Oh crap. We don't have it here. Makes sense. Well, it's fine for this Lloyd file utility function, I guess. The Lloyd shaders, rage and alloy shaders. Yeah, we could use that here. It's fine. So app process heap. Great. So that's basically it. Destroy shader modules. I think that's it for the shaders modules, at least. Now let's create the pipeline. Well, the pipeline is very ridiculously large because it basically holds a lot of state in it. So where to even start with that? No clue whatsoever. Let's see. Vacate creates pipeline. Yeah, pipeline labs is a good start. It's pretty simple currently, at least. So before Okay, hold on. So before we create the pipeline, we have to create the pipeline layout. App. Now currently the pipeline layout would be empty. Not a big deal because we're not using buffers just yet. It would be very, very simple to do actually. I think we could. Can we actually destroy the pipeline layout after creating the pipeline? I have no clue honestly. I mean, I'm just gonna leave it honestly. I only know about shaders. So anyways, so the app should contain the pipeline layout. So vk pipeline layout. Honestly, why not do it first anyways? Is it okay? Why not? I don't think it even matters, but anyways. So create pipeline layout, and let's go ahead and git vk create pipeline layout app get device proc ddr. Great. Now let's actually create the pipeline layout, and yeah, it's that simple for now. Though later on when we want to use the buffers, we have to change this, you know, with state layouts and push constants and stuff like that. Right now it's empty. So yeah, that's too simply it. You just need the pipeline layout anyways. So yeah, okay, great. So create pipeline layout, load the shaders, create the pipeline, and load the shaders. So now for the create pipeline function. This is going to be interesting. Auto calls create graphics pipelines, and let's go. vk, get ready for it. There you go. Oh, wall of text, bro. This is what you use AI for. This is the best case scenario for AI. Boilerplate. vk create graphics pipelines. Okay. You give the device. And here null handle. Oh yeah, I see. So this is basically the, if I remember, it's pipeline cache. Yeah, I think. Yeah, some cache stuff. We could just set it to null for now. It's fine. But basically you could cache the shaders, or the pipeline actually. So when like the user launches the application again, you could just load in the cached pipeline. So to speed up the pipeline creation. Right? Create info count 1. Yeah, we're going to create one graphics pipeline. Here, basically, this allows you to create multiple graphics pipelines at once for whatever reason. Okay, now we have two stages in this pipeline. We're going to have the vertex shader. There you go. And we're going to have the fragment shader. And both of them have going to go with the main as the entry point. Now, technically, you can have like multiple shader entry points, like multiple shaders in one shader file. I think I actually did that before successfully, though I did had to, yeah, actually, but I don't remember how I've done it exactly. It was something about SPV linking, and let's not worry about that right now. Anyways, right now, but later on I may actually try, possibly off camera, to like make the vertex and fragment shader in the same file, at least the same compiled file. I don't think it allowed me to put them both in the same source file. Anyways, HLSL does allow you to do that easily, but GLSL, there was some interesting challenges. Anyways, whatever. So that's basically it. Here you just tell it which stage it is, because it doesn't know. I mean, both are just shader modules. You gotta tell it which stage that is. So this one is vertex and this one is fragment. The input state, currently we don't have anything interesting there. But later on, when we're gonna have some, you know, actual buffers for geometry and stuff, we're probably gonna need some stuff here. And the input assembly state. Now here you tell it the topology, which is gonna be triangles. Now there's triangles, like there's triangle list, line strip, line list, point list, triangle fan, patch lists and stuff. These are, I believe, for tessellate shader, list with agency. I think one picture speaks thousands of words. Let's look for some topology stuff. Let's just go with, I don't know, Vulkan. And there you go. Okay, great. So yeah, this is point list. Well, this is super small. Why all these are small, bro? Crazy. My video here, my previous Vulkan video. I have improved too much from then when it comes to Vulkan. But yeah. Alright, so I don't know why these are very low resolution. Either way, these are point topology. This one is line topology. This one line strip. This one is triangle fan, triangle strip, and topology triangle list, basically. So just how you want to treat the vertices, right? Do you want each 3 vertices to be formed as a triangle, or do you want them to be formed just as points or as lines, or what exactly? Anyways, this one is also, oh yeah, this one is good. There you go, point list 1 2 3 4 5 6, 1 2 3 4 5 6 line list, line strip, here we go. And the triangle strip is like this, 1 2 3 4 5 6. Now in triangles, what you would do to make 2 triangles is that you would say 1 2 3 4 5 6, right? Here you would just say 1 2 3 4, right? So the topology is that the vertices that are after the others are actually linked, like they basically share a side. But in triangle list, that's not necessarily the case. That's why you gotta, you know, have double the vertices when it comes to this side. Anyways, whatever. So we're just gonna go with a triangle list, and I honestly do not recommend too much the others ones. Usually we just go with triangle list. Anyways, I mean, it's fine, the other ones, but like the best, I think, optimal one is the triangle maybe. Anyways, viewport state. So viewport count. Now this depends if you want the viewport to be dynamic or static. What I mean by that is, do we want to specify the viewport each frame, or do we just want to specify every time the every time basically, yeah, every time the swap chain gets resized, like the window gets resized. Now, if you make it static though, you have to, every time your window gets resized, you have to actually recreate the whole pipeline from scratch. Not a great idea. Unless if you're, I mean, honestly, even if you are 100% sure it's not gonna get resized a lot, even then it doesn't really worth it, honestly. Like, at least the viewport. There is some other states that does worth it to make it static, so you have to recreate the whole thing. But viewports, just give it one every frame, just make it dynamic. I don't think it's necessary to specify the viewport state, honestly, here, because we're gonna specify it later on anyways. So maybe we could leave it as 0 or null or whichever. Otherwise, the validation layer would tell us. The rasterization state, line width 1, great. That's the default. If you want anything else, I believe you had to enable a feature. Okay, anyways, so here we got some interesting stuff. We got the call mode that I talked about earlier. So like you could say vk call mode, either none, back bit, front and back. So basically what triangles you want to call, you want to hide, you don't want to render essentially. So so by default it doesn't call anything. So both the faces of the triangle, like the front face and the back face, renders, even if it's not visible. The back bit would actually call the back face, so only the front face would show up. The front bit, the opposite, front and back would call like the whole triangle, like both faces basically. So nothing renders essentially. But yeah. So in my case, I would go with vk call mode back, right? So we don't have to draw the triangles that are inside the mesh, because usually that doesn't show up. Right, but for now I'm gonna go with call mode none. Later on, so just for debugging purposes, and then later on I'm gonna enable it. So other than call mode, I'm gonna go with front face. Now I believe the tutorial uses CCW, so like vk front face clockwise. Actually I think the tutorial uses clockwise, and it is important because, well, the shaders that we have compiled have the geometry in them and the order matters, right? I think the tutorial uses front face clockwise, probably, if I remember, unless if they changed it, but yeah. And that's and it doesn't really matter in this case, at least, since we're setting the call mode to none currently, and none I believe is 0, which is like the default value, so we don't even have to specify this right now, at least. Clockwise 1. What about anti-clockwise then? Or counterclockwise? Yeah, is it 0? Yeah, it is 0, so the default is counterclockwise, which I prefer, honestly. But let's just go with clockwise because I think the tutorial used that for now. Later on I could just change the order of the vertices and change it back to anti-clockwise. Anyways, multi-sample state, this is for multi-sampling, MSAA. So geometry doesn't look jagged in the edges. You know, they look much smoother, but of course at the cost of performance, because you're going to be sampling multiple times per fragment, or maybe per pixel, I'm not entirely sure, probably per fragment, but IDK. Anyways, flags, next. No need for this stuff for now, I believe. Otherwise, the validation would tell us that we're missing something. So that's great. Color blend state. Now this is the part where you would want, if you want to handle transparency. In our case, we're just going to keep it simple. Blend enable equal vk false. Okay, which is 0, so we don't even need this then. Okay, anyways, so the layout, and finally the render pass. Oh yeah, I forgot about the render pass. Interesting. I'm gonna come back in a second. Okay, I'm back. Hello, whoa, GG, Kieran, welcome to the live stream. How is it going? Long time. Renderpass, vacant null handle. Okay, so we gotta create the renderpass and the subpass too. Yeah, the pipeline is crazy. Okay, fine. Let's go app renderpass. And finally, here we're gonna get our pipeline. Okay, great. And finally our subpass. Subpass. Yeah, just 0. Okay, cool. We're gonna have only one subpass and it's 0, so we could just omit it. Okay, cool. Did I miss anything? Base pipeline handle and pipeline index. That's 0. I'm not using those. Dynamic state. I probably missed dynamic state. Tessellation state. Huh. Is this new? I never seen it before. Interesting. Depth stencil. We're not using that yet, at least. We're not using 3D just yet. P viewport state. Okay, so we probably need dynamic state if I haven't done that already. Or should I say if the AI haven't done that already? Yeah, we need that actually. Let's go. So the dynamic state is gonna be vacay pipeline dynamic state create info. Pipeline dynamic state create info. Let's go, man. And let's see. So 2 things would be dynamic, probably the scissor and the viewport. So that's great. Dynamic state count 2. Now app renderpass. Okay, cool. So let's actually declare the renderpass and let's declare the pipeline. And let's declare the pipeline. Oh well, there's a lot of pipelines here. Let's declare this field. There you go. Great. Amazing. Alright, so now we're gonna need to actually create a render pass before even the pipeline. And the render pass is very interesting. I still don't understand it fully. But we'll see about that. We'll see. We'll see. Right. If I used a dynamic rendering extension, I don't have to use that actually. A render path but then I would have to do the synchronization myself. Honestly, for now, let's stick to the tutorial. Later on, we may use dynamic rendering to get rid of the pesky render paths and the pesky frame buffers. Anyways, for now it's fine. So we've come a long way so far. I'm not sure if we can get a triangle today. We'll see about that. I'll try, but we'll see. So let's create the render pass right now. Create render pass before the pipeline. Maybe. Well. I mean. I mean, it doesn't really matter, to be honest. Let's do it here, maybe. Fine. Doesn't really matter. Create global function, create render pass. Okay, cool. So let's actually do this. So render pass, huh? Okay, let's actually load the Vaki create Renderpass. Let's go based AI, and there you go. So attachment count 1, true. sRGB, great. Samples 1 bit, great. Lloyd OP clear. Store, cool. Initial layout undefined, it's 0, so no need to even mention it. Final layout presents sRC, good. Subpass count 1 and subpasses. Pipeline bind point, graphics, and color attachment count equal 1. Attachment 0. So this is the thing that I've talked about before when we were creating the actual shaders. Remember the location? Here. Location equals 0. Well, this is it. Okay, so this is the location of the attachment, color attachment. So there you go. Vacate pipeline bind point graphics. I think this is, oh yeah, it's the default, so no need to even mention it. Can omit it. And yeah, anything that we can omit, let's omit. Store OP store. So let me try to kind of explain what's going on here. So we created a pipeline. I think that's very understandable. It's just a bunch of state code, which includes shaders, Renderpass, blah 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 blah, whatever, you name it. It's a huge state thing, right? So like for each combination of shaders, you would create a pipeline. For each combination of state, you would create a pipeline, basically, etc. There is some extensions to make that more dynamic, I guess. But well, anyways, other than that, shaders are pretty self-explanatory, I think. Pipeline layout, I don't think I can explain this until we reach the point where we're actually going to use this. We're going to use it until the buffers, where this would make sense. But right now, it's just a pipeline layout. We give it to the pipeline and that's it. But yeah, later on, I'm going to explain it once we get to the buffers and once we actually need it. Now, the render pass is interesting. So, where to even start with this? Okay. Let's see. How would I describe it to my past self if I were just starting? Hats, welcome to the stream. How is it going? Long time. Dynamic rendering. Yeah, I'd like to use dynamic render later on. Right now, let's just stick to the traditional way of doing it. Then, because I'd like to try later on, I'd like to try this new synchronization layer to see if it really works. And I'm not confident because like when I use actual like manual synchronization, I get some errors using that and I have no clue how to fix them. So I'm gonna try to stick to render passes and stuff, like to the tutorial stuff, synchronization stuff, so I could try it to make sure I'm not going crazy and it's actually maybe a bug in the thing. Or but yeah, anyways, so let's just say that the render pass is like the layout of the pipeline, but well, we already have a pipeline layout. I mean, honestly, it's not very good name, to be honest. It's, maybe I can call this buffer layout. I don't know. Pipeline buffer layout. I want to make two transparent plane intersect, but one plane behind not shown. Well, for that, you probably have to the color blend state. You have to fix that. For transparency, you have to do some. You have to configure these alpha blend enable and stuff like that properly. Otherwise, transparency wouldn't work. You also have to make sure you have a depth buffer. Other than that, it should work. Just look into the tutorial, some tutorial of blending, color blending for transparency, and it should get fixed. So yeah, great. So yeah, let's just say the Renderpass is like the template to the pipeline, right? So it kind of like the template of the Framebuffers, but I haven't described Framebuffers yet. Well, let's just ignore that for now. But I'm gonna try to explain things that I can explain easily. So the format is pretty clear. So we got one attachment, right? Renderpass are what defines to what the results of the pipelines are written to, kinda. Anyways, so here we have the format of our Swapchain image. This is gonna match, right? Otherwise, we're gonna have a problem. The samples, we're not using multi-sampling, so it's 1 bit. The load OP, this is what happens when the image first get loaded. Well, not first get, like what is the first thing you do to the attachment or the Swapchain image in our case? In our case, we just clear it. We clear it with some color, right? We're going to give the actual color later on. Create everything every time. Kareem, alhamdulillah, welcome to the live stream. How is it going? Long time. Create everything every time. Yeah, Renderpass, creating Renderpass is not a great thing to do. But later on, we're gonna use dynamic rendering. We can get rid of this pesky Renderpass. Anyways, so store OP, store. This is what happens after the Renderpass, or like after the rendering basically. So this is what happens before rendering, and this is after rendering. After rendering, we actually want to store the rendering result. We don't want to discard it, you know. Later on, for multi-sampling, we're going to have multiple attachments. We're going to have 2. And we're going to have 1 that we're going to actually discard because we don't need the result. We're just going to use the result in the second attachment and so on. But anyways, let's not overcomplicate it for now. Let's leave it at that, I believe, until we need some. But for now, let's just take this as boilerplate. Is the one number to live used to our Vulkan from scratch? Yeah, true. Final layout. Image layout presents SRC cater. So before we had like an initial layout, which is initial like undefined at first. We don't care about the initial layout in this case at first, before rendering. But after rendering, we do care about the layout. We want it to be presentable. We want to be able to present it to the window, right? Or to the surface, or to the swap chain. So we have to make sure it's the proper layout. So like the layout is, I didn't get Renderpass from any book or tutorial, just when I was debugging Vulkan frame, I get it. Yeah. For the layout, the image layout, how can I describe it? Is like, let's say you're implementing a matrix, okay? Now, let me see if I can find some good image actually that describes that. I don't have to make it undefined because undefined equals 0, and since I'm using, you know, what is it called? I'm using designated initializers, yeah. Since I'm using designated initializers, it automatically gets set to 0. And if you see here, undefined is actually 0 already. So I don't have it. Yeah, I don't need it. I can just omit it, at least undefined. So value 0, yeah. So I don't need that. So basically, in an enum, in a C enum, when you want something to be the default, you set it as 0. So that's pretty cool. Load OP clear. This is 1. So yeah, other than that, we have one subpass. You usually have one subpass, pretty much. Color attachment count. Anyways, let's not waste more time on this for now. Later on, maybe we could try to get into more details. And honestly, even myself, like after 1 year, I guess, or I don't know how much I've been learning this, and I still don't understand subpasses and synchronization and render passes fully. You know, I do understand some, not fully. There's just a lot of crazy stuff right there. Just you take color attached from last command record, which can modify both color and depth buffers, and then you can override them in second pass like layers of render things. But you still have to, nah, it's like, it's all about synchronization. Like, you have to think about someone who's just starting out as a beginner, how they would see this. I'm trying to put my shoes, like, how do you even say it? Trying to wear the shoes of someone just beginning, like me last year, I guess. Anyways, whatever. So for now, let's just take, if you don't understand it, it's fine. Just take it as a boilerplate code. Anyways, it's not a big deal. What is a big deal is the actual shaders and like the actual pipeline. I mean, the actual graphics programming, which is the pipeline and stuff. Anyways, whatever. Rename this parameter. Sure. Okay, cool. So we created a render pass now. Great. Did I miss anything though? I don't think so. There is stencil, which we are not using yet until we have some stencil. All right, cool. So we have the render pass. I think right now we could run, and if there's any problem, our code would break. Just make sure the validation is on. Okay, yeah, we need this. Let's find out. Okay, we got a validation error in create graphics pipelines. Let's see, rasterization is enabled. Rasterizer discard enable is vacay false. But viewport state is null. Requires pre-rasterization. I mean, I did set the dynamic state, no? And it's basically saying to me that I didn't set the viewport state, unless if I made it dynamic, but I guess I did, no? Dynamic state count 2, and I'm sitting here, the viewport is dynamic. I mean, it should work. Unless maybe if it needs the viewport anyways. I mean, it did include those some other variable thing. It said vacay discard enable. Hold on. So rasterization state, rasterizer discard enable is vacay false. I mean, yeah, it is supposed to be that way. I mean, let's just go ahead and do that anyways. Viewport state. It should not be needed, since it's dynamic, but well. What's up? What happened here? I broke this thing somehow. Okay, go back, Control Z, savior. Okay. So P dynamic state, comma, yeah, and dot viewport state. AI, come on. Okay. There you go. Come on. Let's go. Viewport count, scissor count, and I think we have to set the P viewports, yeah? Yeah, set it to just something, I guess, right now. Don't care. And there you go. Let's see if this works. Huh. We didn't get any error though. Stick trap. Where? Oh, in Lloyd shaders. Interesting. Interesting. Where exactly? Heap free. Okay. Oh, I see. I see. I see. I need the bytes actually. Yeah, but I didn't store them. Interesting. Okay, sure. But also another thing, I only freed one thing. I need to free two things. Yep. Fragment shader bytes. Great. Let's actually create this field, I guess. And in Lloyd shaders, let's create this field too. And this LP void is disgusting. And yeah, in Lloyd shaders. Now I gotta make sure in Lloyd shaders. What are the bytes? Like perfect? Yeah, exactly. It's binary. So after loading the file, we put it in the vertex shader bytes. Okay. And then we're freeing them. Okay, cool. I think that's correct. Unless if I missed something again. Oh crap, hold on. Oh. Yeah, no. I don't know why it didn't crash now. Interesting. Anyways, so I should remove this. I don't think I need the size, at least for now. Delete them just after creating shader mode and then store them. Yeah, I would have done that, but then in the pipeline I would have to well, yeah, that's what I'm doing exactly. It's like here what I'm doing, let's see. So I'm saying create pipeline. So load in shaders, create pipeline, then unload the shaders, right? So after creating the pipeline, I'm loading them. So yeah. Okay, so where I was. Oh yeah, I removed those, I guess. Yeah. And I gotta make sure now that we're doing this instead. App fragment. Oopsies. I think this is good now. Possibly. Okay. Seems fine so far. Cool. Okay, great. Great. What else? What else? So we have created the pipeline and stuff. Yeah, well, let's create this. Since we have the Renderpass now, we can create the frame buffers. Cool. So let's go ahead and do that. Okay. Void, or yeah, pretty much. Let's create the frame buffers. Let's go. So Vaki creates frame buffer. Okay. Renderpass, attachments count, attachments, width and height. Ooh, actually I should honestly store the extent. Yeah, I should store the extent. of the images. So let's go ahead and say, I think it's vk extend 2D or something. Yeah, Swapchain extent. And let's see where we're actually setting that. So we're getting the capabilities here, and we could too simply say that app Swapchain extent is equal to the current extent, and there you go. And yeah, pretty much. Now we could hopefully use that. So app frame buffer. Well, it's gonna be frame buffers, I guess. No? Oh yeah, we need to make a for loop, I guess. Yep, probably. For vk creates frame buffer, app frame buffers I, layers equal 1, swapchain extent. There you go. Cool. Swapchain image views. Let's go to its declaration and let's make some frame buffers there. There you go. I'm not allocating, by the way, the swapchain images. I'm just, you know, making it into an array. So yeah. Frame buffers. Cool. So let's go ahead, make sure we're doing this correctly. Create frame buffer. Now the thing is, we also, since we created it, we have to destroy it. Since this would be called multiple times, like every time it's get resized, it's not a one-time thing. So vk destroy frame buffer. So if app frame buffers 0, by the way, make sure to not do app frame buffers like this. No, do 0, because an array would always be not null. So we're getting just the first element and seeing if it's 0 or not, you know. Okay, so for I equals 0, swapchain image counts plus I, destroy frame buffer. So if there's frame buffers already there, we're gonna destroy them too simply. No need for those. And let's go. That's basically it for the frame buffers. Now in our swapchain dependence resources, where is it? There you go. Yeah, after configuring the swapchain, if we have, hold on a second. Now the problem here, we have to destroy the frame buffers before the swapchain, I believe, maybe, just to make sure. I mean, maybe not needed. Either way, I think it would be more appropriate to, instead of doing it this way that I've done it, instead of doing it this way, let's just go with void as we had before. And we're gonna remove this from, yeah, and honestly what I'm gonna do, I'm gonna take this part right here, the part where we get the swapchain, like the surface capabilities, and then put it into its own function, I believe. So old swapchain, blah blah blah. Okay, so let's grab that part, put it with its own function. Let's take this, copy it over, or cut it, should I say. And yeah, and here it would become app surface capabilities. And let's go. Function void cannot return a value. And now we're gonna make another function called either update surface capabilities, I think. And yeah, I already have done it. I didn't even need to paste anything. Interesting. Chain create field. Let's go. So there you go. Anyways, let's put it there, I guess. And there you go. So now that we got the surface capabilities, so let's see. Still analyzing too slow. Alright, so here we're creating this. We're saying, now I'm gonna remove that Swapchain extent. Actually, we don't need it anymore. I should have just made the surface capabilities from the start. And here we're just gonna say app Swapchain, surface capabilities dot current extent. So let's go. And I'm not sure why they didn't use extent here instead. Huh. Win32T. Weird. They should have just used their own abstraction, I guess. Or should I say struct? Anyways, whatever, who cares? Height and layers equal 1. And that's basically it. S-type. Yep. Seems good to me. Or we could get the extent here. And just say this. Colonel Panic, welcome to this live stream. How's it going? Late to the stream, but it seems I'll be busy watching this tonight. By the way, any good books you recommend for learning Win32? Linux user here. Welcome to the stream. Good books. Actually, there's no good resource on Win32, unfortunately. I just had to learn it the hard way, I guess, and just searching up stuff constantly, pretty much. But yeah, it's like there's no resource that I could give you other than the documentation, really, unfortunately, for Win32. There's actually some videos that are interesting, some new videos. I don't have my monitor right now, so don't know if I can. Let me see. I believe it's Crow or something. Oh yeah, let's go. Maybe this guy. Yep, this guy isn't bad. He does have some interesting videos on Win32. This one isn't bad. But still, it's really not gonna give you too much. But like the best currently, I think, is the documentation, pretty much. So yeah. You're welcome. So let's see what we got. Width and height. We're not even setting that, so no need. Probably same thing with this one. Yeah. There, we're just setting those to 0. So. Okay, cool. So other than that, is there anything? Wiki erect. I honestly don't think it even. I'm not sure why. Like, I mean, I'm putting this as dynamic state. It shouldn't even require me to do this in the first place. So, anyways, I don't know if I'm doing something wrong there, but whichever. So now we got the frame buffers, we got the render pass, the pipeline. Next stage is command pool, command buffer, and finally we could actually start the code that actually does some rendering. Oh crap. Let's see. So let's create some command pool, I guess. Create command buffers. Well, not create, allocate command buffers. And after that, what we're gonna do? Yeah, we're also gonna need to create some synchronization objects. Primitives, just say objects, I guess. Let's go. And yeah, after that we're gonna do the rendering, not here, we're gonna do it in the actual window procedure. And I'm gonna show you something interesting once we get there. That you cannot, at least, yeah, probably cannot do with anything else other than using Win32 directly. I'm not sure though, but like so far all my attempts to do it in using other libraries like GFW and SDL was a total failure. Anyways, we'll see. Let's get this working first of all. Create command pool. Another interesting thing with Win32 is that we could mess up with some crazy virtual memory stuff to do some weird things. Anyways, so yeah, vacate create command pool, get device proc address, and then key family index, it's equal to 0, so no need to specify it. Other than that, we're gonna need some flags, I believe. Yes, so yes sir, let's go. AI, come on bro. Command pool. I mean, come on, I gotta do it myself. Okay, sure. Vacate command pool reset. Flag, right? Yeah. So there's the reset flag bits. Yeah, I believe that's it. Ooh. But no, that's the max enum. What the heck? Really? Okay, there you go. So command pool create reset command buffer bit. I believe we're gonna need that, yeah. Maybe not. Yeah, we're gonna need that actually, yeah, bro. Let's go. Okay, cool. So we have created the command pool. Next up, we're gonna allocate some command buffers. Okay, the AI doing a good job. Let's go. Level primary. This is 0, no need to specify it, just omit it. Command pool, app command pool. Yeah, we gotta make this field. I haven't made that field yet, interesting. And we're also gonna need, well, we're gonna need command buffers. I'm gonna reorder these things consistently, hopefully somehow. What? Yeah. Make it command buffers. It's also gonna have max Swapchain images. No, actually no. It's gonna have that. Yeah, it's gonna have in-flight fences. Actually, not this. Yep. But we're not gonna do in-flight fences just yet. For now, let's just start simple with one command buffer. Actually, yep, pretty much. Let's go with that for now. Yeah, we're also gonna need one semaphore, well, two semaphores, one fence. Okay, later on we're gonna actually need multiple of these for in-flight frames. For now, let's start simple. Okay, cool. And then what we gonna do? Let's go. So allocate command buffers, Swapchain. Nah, just allocate one for now. And what else? Did I miss anything? Level. Okay, that's good. Here we're gonna go with command buffer actually. Imagine if we get a triangle in one video. Last time I needed 7 episodes to get one triangle in Vulkan. I mean, we're pretty close, unless if I missed something crazy. Yeah, okay. So create synchronization objects, allocate command buffers. Allocate. Yeah, let's create synchronization objects now. Okay. Alrighty. Create semaphore. Oh, the AI, bro. Let's go. There you go. Man, I just cannot make Vulkan applications without AI doing the stupid boilerplate. Like, bruh. Imagine me typing all of this. Crazy. Crazy. Let's go. So Vaki creates semaphore fence. One thing, the fence should have some flags. It should be signaled. And yeah, I believe that's it for the synchronization objects. Too simple. And yeah, let's go. Is everything good so far? Let's see. Copilot worth every penny. Yep, kernel panic. Console. Okay, so pre-transform must be valid. Vacay service transform flag bits. Interesting. We have missed something in the pipeline, right? Or is it? Yeah, actually Swapchain. It's weird that it just catches it right now instead of before. Pretty sure we have tested this before. What the heck? Oh, it's probably not initialized. Gotcha. It's probably not initialized. I missed something. And are we actually calling the update thing before the Swapchain stuff, etc.? Let's see. By the way, if you guys didn't notice yet, since you just joined, I don't have any error handling here. I'm getting error handling through the Vulkan configurator, validation, and then making it break on some error if an error happens. I'm only handling errors that are likely to happen, that are, like, for example, a file not being found, or let's say Vulkan driver not found, or something similar. That's the only errors that I handle right now. Anything that is possible but usually doesn't have a problem, or at least practically, I don't really bother with it. So it makes it much cleaner to work with, honestly. Look at that. Much cleaner. So let's go. And you may argue a bit more performance, possibly. I mean, it's very minute. Probably less than nanoseconds. I mean, it's just but like the binary size though, yeah, that may be worth it in terms of binary size. Not much, but like just a bit, I guess. You're not have all that bulky, like half of your code is just error handling. But yeah, anyways. So what's up now? Yeah, we need to update that stuff. So where's the swap chain, bro? What the heck? What? Oh yeah, it's in the procedure, the window procedure. Let's go. Okay, so yeah, we're actually calling the swap chain dependent setup. There you go. So here we're configuring the swap chain, and after configuring the swap chain, we have to create the frame buffers, or should I say configure frame buffers? So basically, why instead of saying create, I said configure, because basically, while the create functions are only meant to be called once, the ones that have a configure in it instead of create are meant to be used twice, or not twice, like multiple times, like to be reused. So because those functions that start with configure mind, like, it makes sure to actually recreate instead of create when the resources are already there, basically. Anyways, so create frame buffer. Oh, I'm actually even calling it frame buffer. It should be configure. Oops. What? Let's go. So I'm gonna call this actually configure frame buffers. Let's go. I think that's basically it. There's an error here. Where? Oh, here. Okay. So why? Cannot resolve symbol configure. Yeah. I see. Where's configure frame buffers? Declared. Okay. Here. Let's take this. Finally, let's go. We had to travel. Okay, cool. Let's go. Nice. Configure swap chain, configure the frame buffers, and we also, I'm gonna make sure that the app, no, if app, what is it called? Surface capabilities, yeah. The current extent.width equals 0. Also, I need to update, first of all, I need to update the surface capabilities, right? And then if the current extent width, well, let's actually store the extent. Okay. Well, not void. Auto const extent equal to that, and or this, then return. Yeah, pretty much. So that seems good. That seems good. Great. I think we're good to go, because we didn't update the surface capabilities before, basically. And yeah, we have no crashes, at least. We're not gonna know if this actually works until we start rendering. But well, we have no validation errors, at least, and no seg faults. So okay, cool. Now I believe we're gonna start the rendering stuff, right? So let's go to the window procedure. There you go, in the handle message function. Now we're gonna go to case wmpaint. Now, as long as you don't invalidate the rect of the paint event or the paint message, it's gonna keep on calling that message every time. So it's like polling. So I don't really have to use peak message to poll. I could just keep get message and it would work just as expected, at least I think so. We'll see. All right, so case wmpaint. Here where we're actually gonna render. Right. Gonna go with app and void render. Const app. Let's go. So what we're gonna do now? Yeah, now we're gonna need to load some functions first of all from the library. vk acquire next image khr. We're gonna need that. Yep. We're gonna need vk q submit. Sure. Q present. Sure. What else? Reset fences. Yep. What else? Begin command buffer. Sure. And yep. Begin render pass. Yep. Go on. True. No, not this one. So we got reset fences, but we didn't get wait for fences. I think maybe this is it. Probably. CMD bind pipeline. CMD. Oh, we actually need also vk. What is it called? Let's see. Yeah, set viewport, I think. CMD. There you go. Based AI. Let's go. Alright, so I think maybe this is it. No, we don't need that yet. Okay. Alright, so first of all, we're gonna reset the. Well, actually, we're gonna wait for the fence. Yeah, gonna wait for the fence. So, well, no. Let's go. Reset the fence. Great. Though we're gonna change the position of that later on. Anyways, fine. Next up, acquire next image khr. Lovely. But before that, let's actually say uint32 image index based AI. Let's go. Right. After that, after acquiring an image, yeah, we're gonna allocate some buffers. Actually, we did allocate the buffers. We have to reset the I don't think we have done reset buffers, right? Yeah, no, probably not. There you go. And vk reset fences. Reset command buffer. And finally, we're gonna start recording some commands to the GPU. So begin command buffer. Is there anything we missed here? We probably want to change the, actually not sure, I don't remember. Anyways, whatever. vk and begin render pass. Great, lovely. So render pass, lovely. Framebuffers image index, great. Offset 0 0, amazing. We don't need any of that actually. In fact, we don't even need to specify this. Other than that, clear value count equal 1, good. color. This is the clear value. Let's go. Rich. Is there anything else we missed? Nope. Great. All right. So after beginning the Renderpass, you gotta set the pipeline and set the, there you go, and draw. But before that, you need to set the end command buffer. It missed one thing, well, two things. So I'm not sure if before or after, but I guess let's go after. And let's say vacate CMD. There you go. It made up for it. So let's go. That's what I'm talking about. First scissor viewport count. Cool. Yep, that seems about right. Though it's weird, this inconsistency in the API. Sometimes they ask for the whole extent struct, and sometimes they take width and height separate. Not sure why that's the case, honestly, but anyways. So after end command buffer, we gotta submit it to the GPU through a queue. There we go. So, oh, we didn't get the queue. I forgot about that. Yeah. Let's go back where we create the device. There you go. And let's make sure to do that. Okay. Oopsies, no. Get device. Okay. Q? Is it? Alright. I'm pretty sure this whole code won't run from the first try. I'm just not that lucky. Q index, key family index 0, yep. Vacate Q. Where's the device? Oopsies. Let's go here. And yeah, let's go back now to the render function. Let's go. Okay, so CMD set scissor, CMD draw, and Renderpass and command buffer. Great. Now let's actually submit it to the GPU. Let's go. So image available semaphore based AI. Let's go. Nice. And next up, we gotta present. Right? Yep. AK Q present kchar. Let's go. Alright, I think this is it, isn't it? Did we miss something? Let's see. Can be made pointer to const. Sure, why not? Why not? The render function doesn't mutate any state. Interestingly. Okay, makes sense. At least for now. And okay, we have some syntax error, nothing fancy. Missing braces around the initializer. Huh? What? What are you talking about? So it says to... Man, these errors are not as good as Rust errors. Okay, what's up? Missing braces around the initializer. Maybe in color we actually need to do this way, because maybe it's a union if I remember. Yeah, yep, gotcha. Float 32. Because like, depending on the format of the image, you gotta set a different color. Interesting. So since we have sRGB, we gotta use float 32. Error, the statement may fall through. Good warning. Good warning. return 0. Come on, really? Oopsies, no. We're not finished. When you resize the window, something goes wrong. Make a destroy image view can't be called on. Must have completed execution. Makes sense. We have some order problem. Not a big deal. Let's see. So let's go to the Swapchain dependence resources stuff. There you go. And we have so update surface capabilities. Creating figures out chain. Oh yeah, I see what's up. I think so. Basically, we need to destroy the frame buffers before we destroy the so that means we gotta slice this up a bit. So we gotta destroy the interesting. Though we can actually do something pretty I mean, yeah, I guess we just gotta basically split this up a bit, I think. So basically we need to destroy, where is it? Configure frame buffers. Configure Swapchain. Yeah, pretty much. I mean, we gotta slice this up a bit. So what we're gonna do essentially is if we're gonna take this basically and we're gonna call this I guess destroy frame buffers. Yeah, I already done this job. I didn't even need to paste again. Okay. What's up? Add const, sure. Okay. Actually, yeah, good. Now what we're gonna do basically is configure. So before we configure the swap chain, which also configures the image views, we're gonna destroy the frame buffers. App, I think, right? Maybe. Let's see if this works. Another crash. Interesting. Console. So they can destroy. Ah, I gotcha already. I didn't even have to read the whole thing. The version must have completed. Yeah, makes sense. Makes total sense. So the thing is that we should do, what's happening here, we don't know when the resize event would happen, and it could happen while the command buffers are busy. They're already submitted. So how we should actually fix this too simply is by making a variable, and so basically we're gonna say this. Hold on. Where is the swap chain variable stuff? Okay, cool. Let's say boolean. Is swap chain outdated? OBS I've disconnected. Okay, so OBS disconnected for some reason. I guess it's back again. Let me know, guys. Actually, let's call this a swap chain invalid, or as they call it, dirty. Fine, let's call it that. Swap chain dirty. Cool. Oops. Swapchain dirty. So let's look for the WM size. Okay, now instead of doing this, in fact, let's just say is Swapchain. In fact, let's just say this is app Swapchain dirty equal to true. Right, great. And what else? And now in the render, right? So after we wait for the fences and we reset them and stuff like that, what we're gonna do is if Swapchain dirty, then we're going to reconstruct that stuff. And of course, let me make sure to do Swapchain dirty false first. So yeah, let's make it mutable. I can never remember the const order in C. Anyways, cannot resolve symbol mutable. What the heck? What? I told my IDE to make the pointer mutable, and this is what it did. Are you kidding me? What language is this? Oh crap! I mean, I would have understood if it said mute. I would guess. I thought maybe it's Rust, mutable. Okay. Anyways, so I believe this is it. And let's see. Oh, okay. Oh, let's go, man. And did you guys notice something interesting? Did anyone notice anything interesting here? Yeah. Does not contain 0. Okay, cool. So let's do this. Where is that thing? Render function. Yeah. So the thing is, but I guess we gotta do it after we make sure that the Swapchain is not dirty. And we could actually do it even before loading anything, really. And then, if current extent with height return. Okay, cool. So I guess that's basically it. What is currently in use? Oh, my bad. I see what's happening there. Okay, cool. So makes sense. I actually gotta do it this way then. We gotta wait for the fences first. Yeah, pretty much. Huh? It doesn't crash, but it blocks up. It locks up. Interesting. I think it's probably maybe resetting the thing. Hopefully this works. Yeah, there you go. Nice. Very nice. Let's go. And there you have it. Win32 with Vulkan. No libraries got harmed in this string. All in one single stream. There you go. Great. Did you guys notice something here that is different from other Vulkan triangles? Or at least most of them. Let me show you. Let me see if I can find something. No. I need some. Either way. So the thing is, let me try to do it. Let me just tell you. Let me just tell you honestly. Fine. So the thing is, the triangle, the resizing is very smooth. Like while resizing, it still renders, because instead of just like in Windows, what happens is that if you use polling, if you're polling like in GFW and SDL, what happens is when you're resizing the window, the thread blocks up. The thread gets suspended, so you cannot render or do anything until the resize is done. So what happens is that while you're resizing, the thing doesn't render until you're done, which is super junky. But since right now we're using Win32 and we're using that window procedure with WM Paint, right now we're actually rendering while resizing. So that's perfect. Let's go. It's very smooth. Man, let's go. So that's pretty much I guess. That was very fun. I wonder how much it took. Oh crap, it's 5 hours. Okay, pretty cool stuff. Pretty lovely. So I guess we're gonna stop the stream here for now. That was very fun. And actually before that, let's just do a little thing. A little thing, which is, so remember when I told you that it's the performance does matter when it comes to the render function. Actually, we still haven't done the frame fences stuff. Honestly, let's leave it to the next episode so we can fix all that stuff anyways. So that was it for the stream, and see ya in the next one, probably tomorrow. So that was it for the stream, and see ya. Goodbye everyone.